Charlie ma'am, it's live now.
Okay, sir. Thank you. Thanks a lot.
Shalini madam, idiralli.
Good morning, sir.
Very good morning. Start ಮಾಡಿ madam.
Okay, sir. Okay. Harshita?
Yes, ma'am.
We can start. Sir.
Okay.
Sir, I think your audio, video and all should be on.
No issue madam, ಮಾಡಿ.
Sir, yeah, start Harshita.
Yes, ma'am. Thank you. A very hearty welcome to all the delegates and the student members, IEEE student members, and the participants present here to attend the workshop. We are happy to announce that we have more than 500 registrations for this workshop. Firstly, I would like Jessie Joyner to give the welcome speech.
A very good morning to one and all present. I, Jessie, member of IEEE Student Branch, AMC Engineering College, on behalf of management, would heartily welcome in their absence respected Director of AMC Engineering College, Dr. Mallikarjuna Babu, beloved Principal, Dr. Girisha C., HOD of all respective departments, IEEE Student Branch Counselor, Dr. Janita J., today's resource person, Professor Shalini S., team members of IEEE, and dear participants. I extend my warm welcome to all who took their time to join us today as we talk about an interesting topic on IoT. I'm sure you will have an engaging and an enriching session ahead. Thank you.
Thank you so much, Jessie. We now have a few encouraging words by our HOD CSC.
Shubhodaya, good morning. Good morning, Shubhodaya.
Good morning. Good morning.
Good morning,
sir.
sir. Good morning, sir.
Yeah, it's a great day for all of us for few important reasons. First and foremost thing is, in this pandemic situation, we are trying to highlight the importance of IoT. We are going to demonstrate how projects can be done. In this regard, I would like to highlight few important things. One is PC. We all know what is PC. PC is all about personal computers. I do agree. But there is another version of PC in the spiritual world. PC means passion and compassion. For all young budding engineers, okay, your passion for learning is highly appreciated. But at the same time, if you look at pandemic, compassion is also important. What I would like to suggest through this workshop is using PC, using IoT, using technology. If we can provide some solution for people who are suffering from pandemic, widows who are suffering across the globe, okay, and all human beings who are having problems. If we can develop some hobby projects which can enhance their life standards, which can make their life comfortable, I think the goal of this workshop will be very much taken care. I'm always fascinated by two characters in English language. One is P, other one is S. Let me list out what all possible P words are there in English. As I already told you, one is passion, second one is problem, third one is project, fourth one is process, fifth one is product, and sixth one is project planning. So all these have a very significant role on the society. So S means society. Okay, you have a project means there should be a schedule for project. If you have a project, you need to have a guide for your project. You have your Professor Shalini Madam as the guide. So she also represents S. And all these yes, when all these P and S, if they come together, they give you a lot of success. I hope this workshop will be a great success. Internet of Things, I do agree. Internet has changed the world. It has changed our life. Internet has made the whole world a global village. I do agree. But with Internet of Everything and Internet of Things, it is again going to change all of us, the way we think, the way we live, and the way we solve problems. Cloud computing, Internet of Things, big data, AI, ML, these are the technology which is going to revolutionize the whole world. We are in a global village where we are going to contribute for the growth and success of the society. This concept of Vasudeva Kutumbam means the whole world is one family, and concept of global human being, that's what we would like to promote through this workshop. I take this opportunity to thank all people who are involved in organizing this workshop, in supporting this workshop, for allowing us to conduct this workshop, whether it can be IEEE, whether it can be the top management of AMC Engineering College, starting from our beloved chairman, sir, executive vice president, sir, our director, sir, our beloved principal, sir, head of the department electronics, IEEE chairperson, all my young budding engineers who have joined for the registered for this workshop. Special thanks to our resource person, Professor Shalini, and one of our very, very enthusiastic volunteer, Miss Harshini or Harshita, all of you, I hope, and also the alumni will be demonstrating their project. I'll be very thankful to all of you. Few things I would like to highlight. One, as I told, PS. Okay, P means problem, S means solution. That's what I always say. And that solution is for a system making use of software. From computer science, we all think of software. So we would like to provide solutions in the form of software projects through IoT and demonstrate how hobby projects can be a small step for young budding engineers to encourage their passion for learning, to make them understand that there are different types of projects. You have study-oriented project, okay? You have mini projects, you have final year projects. There are so many, you have different academic projects, industry projects. Finally, the outcome of project should be to enhance life standards, to improve the condition of society, and contribute for the growth of the nation, contribute for the growth of the global world. So that's what my intention. I've been very much thankful to our resource person, Professor Shalini Madam. I do agree, she is a very innovative educator. She's a top class academician, and she's been coming out with lot of initiative to support the department and the college. I hope very shortly we will be able to promote her. She'll be completing her PhD very shortly. I would like to discuss with the management to take care of such innovative academicians who are promoting the interest of the student. When Harshita told me 500 registration, I'm seeing only 240 participants. If the participants number increases, we'll be very happy. But we have made a small step. Okay, this small step would be helping us with many such innovative activities. And I'm very happy that Electronics Department of AMC, IEEE Society of AMC Engineering College, Computer Science, we all have collaborated to come out with this workshop. Thank you. And thank you for your wonderful gesture, especially for head of the department, electronics, Dr. Kavita Madam, Dr. Janita Madam, all those people directly, indirectly, Mustaq sir for arranging for this technical Zoom link, both sir, for everyone who is directly or indirectly associated with this workshop. Thank you very much. I hope this workshop will be very successful and we'll see lot of similar workshop, conference, seminars in the days ahead. Thank you very much. I extend a warm welcome to all the participants and I hand over the control to Harshita Madam, Shalini Madam. Thank you very much.
Thank you, sir.
Thank you, Madam.
Thanks a lot for your supportive words. I welcome you all to the workshop, Getting Started with Hobby Projects Using IoT. I thank the management, the director, sir, principal, sir, HOD, sir, and EC department head, and Janita ma'am, IEEE chapter coordinator, for supporting this workshop. I also thank our IEEE chapter students group who are working since a week to make this workshop successful. Thank you, IEEE chapter student group. Thank you very much. Yeah. So I think I can move on to the concepts. Yeah. I usually used to conduct IoT workshops offline for third semester students, fifth semester students at AMCEC. I used to get the components for them and I used to make them as teams and I used to start projects. I used to do workshops. So this time I could not do because of COVID pandemic. So I wanted to bring some knowledge in youngsters about IoT. So I wanted to make them start hobby projects so that when they come to final year, they can do their own projects, that is final year projects. So it is not possible to directly start with the final year projects unless you are aware of some basic concepts, unless if you have done some basic small projects and all. It is really difficult to start with the final year project. Okay. I have seen that the final year students, they struggle a lot because they don't know the basic concepts of, it can be a machine learning, it can be IoT, any other field, website design. They don't have the basic concepts of all this, but suddenly they have to jump into a huge project of 100 marks. So they really find it difficult. So if they start doing projects in the initial year, say in first year, second year, it will be wonderful. When they come to final year, they actually enjoy the workshop. They can enjoy the project. Okay, so I wanted to educate our students, that is especially the juniors, that is first year students, second year students, and third year students about IoT, so that they can start some hobby projects at home. They can get these components online. It is easy. It's not that tough to get the components. They can get the components online shopping and they can start the hobby projects at home. Okay. So that's why I took personal interest in doing this workshop because I could not do it offline. And I requested our alumni to present their projects. So they got KCST funding also for their projects. So I requested them, even they agreed, and they are going to project their project and how they were able to start with the project with the basic skills and knowledge. And I have a set of students from AMC Engineering College who are doing projects with me. They have done some hobby projects, especially for first year induction program. They did hobby projects, though they cannot come to college very regularly due to the pandemic situation. Within a very short span of time, they were able to do some projects, and they are exhibiting those projects. And when we requested for registration, many students came up with the idea of displaying their projects also. So even they are going to display the projects and they are going to come up with the ideas. So I thank everyone who have registered for this workshop. So thank you.
Shalini madam, can I just add few things here?
Yes, sir.
Yesterday in one of the meeting, our beloved, respected director sir, he has requested us to come out with some patents from the department.
Okay.
Since many of our alumni who had worked with you, many of the students who are working with you, they have some hobby projects, final year projects. Think on those lines where it can be converted into research publications. It can be converted into copyrights. It can be converted into patents. It will be very helpful for the department and the college. See to it that not only we demonstrate, teach IoT, we would like to induce the concept of copyright, research papers, patents into our students from first year itself, so that we will have one more workshop on copyright and patents through you only. So we would like to arrange for that. And the attitude of coming out with patents wherein we own our own products, that should be a great idea. I hope you will motivate our students to take that to the next level, madam. I know that you can do it. Whole department would be looking at you to take necessary initiative for that. You have been doing some wonderful work for women empowerment. You are also doing good work for technology. We are very happy for the initiatives you have taken, madam. Thank you very much.
Thank you, sir. Thanks a lot.
Okay, you can continue, madam.
Yes, sir. Thank you, sir. Yeah. We shall move on to the concepts of IoT. As I told you just now, that it is not that easy to suddenly jump into the final year projects. So you need to have some basic skills and basic knowledge about Internet of Things. If you are doing projects on Internet of Things, or if you are doing projects on machine learning, you should have some the basic skills or basic knowledge about all these things, and then only you can switch into it. You cannot do a miracle like that when you come to final year. So there are some students who are in second year, third year, who are completely not aware of the concepts of IoT. So starting few slides, I'll tell about that. I'll give introduction about that. Later, I'll start demonstrating. So Internet of Things. Internet of Things. We know that we can send mail from one place to another place. That is, from one person to another person, we can send mail. Right? We can communicate. It is possible because of networking.
Ma'am, sorry to interrupt you. I think the recording is not on.
1 second.
Yes, ma'am.
Yeah. So you can send mail from one place to another place using internet, right? So one object can communicate with another object. It is also possible with the help of internet. Okay, so objects communicating, people communicating, all these things are possible because of Internet of Things. Okay, so we can use the concepts of Internet of Things to start hobby projects. Yeah, you can see here the whole globe is connected by internet. Home is connected, and you can connect it through phone. You can connect it to a person who is outside the home, and this person is somewhere outside. You can see people communicating, and you can see even plants are communicating. You can see here a plant potted in a plant. Even it is communicating. How it is possible? It's all because of sensors. People can talk to each other. Objects can talk to each other. Objects can send messages about themselves. It is possible because of IoT. So we shall know the definition of IoT. So the Internet of Things describes physical objects that are embedded with sensors, processing ability, software, and other technologies that connect and exchange data with each other, with other devices and systems over the Internet of other communication networks. So we basically need internet to communicate. So it is the ability to send data from one place to another place using sensors, using software, using technologies that makes Internet of Things. So some of the system, weather reporting system, home automation system, smart garage door, air pollution monitoring system, smart parking system, soil moisture detection, fire detection system, and so on. So these are the projects which you can only start. You can start a project for smart agriculture. How you can make agriculture smart? Can anybody tell me how you can make agriculture smart? How you can make
by applying the concept of vertical farming.
Yeah. How you can make agriculture smart with networking technology, with IoT? How you can make it?
Using sensors?
Yeah. What type of sensors? Yeah, that we are going to learn now.
Light sensors.
Yeah.
Moisture sensor.
Okay. So there are different types of
by smart water system.
Yeah, there are different types of technically available components with which we can make projects, and with which we can help farmers, right? Weather reporting system. There are some places like Arctic region, Antarctic region. You cannot go there and stay there and record the weather, right? You can keep weather sensors, okay, to monitor the weather. Home automation system. You can automate your complete home. You can switch on, switch off the lights, geyser, fans, wherever you are. Suppose you have come out of the home few kilometers away, and if you have forgotten to switch off the lights, you can switch it off using your phone, using internet. If you are in the downstairs and if you want to switch off the light in the upstairs, you can do it in phone. You do it with Wi-Fi. See, all these projects, even you can do it. You can do it. Okay. And smart garage door opening. That is, when the car comes, it will automatically sense and it will open the door, and later it closes the door. All these are already existing. I'm not telling you to do some research here. You start with some simple projects like this. You can do it. And air pollution monitoring system, smart parking system, right? Smart parking system saves a lot of time, especially in Bangalore. You will be searching for parking places, right? You will go that side, that road, this road, and finally you get angry and you forget for what purpose you have come for, right? So if you have smart parking system, you will be knowing clearly where the place is free and where you can park your cars, right? And we have soil moisture detection, which helps to find out the moisture content in the soil so that you can use the water effectively. You need not waste the water, right? You can use the soil moisture detection at your home also. You can use it for your parts. You can see whether the water content is less, you can water it. If it is more, you need not water it. You can make the plant to grow in a healthy way, right? And fire detection system, it's very, very important. Each and every building should have this fire detection system. You can do it. You can do this project for your college. Why not? You put a fire detection system in each and every floor, in canteen, right? It's very simple. When fire is detected, the alarm buzzes. You can come out with such projects. There are few examples what I'm giving now. So this is home automation system. Here you can see a person is controlling the home with his phone. Here, this is the parking system. Really, you will be informed where the parking space is available so that you can park the vehicles effectively. Okay, and then in agriculture, you can make use it in agriculture. Okay, so it helps the farmers to save water. It helps the farmers to find out when it rains and all, so that they can water the plants, they can maintain the fertility. Okay, and coming to cloud, when you work on IoT, you should know the concepts of cloud. Okay, cloud computing. What is this cloud computing? See, you cannot store more data in your system, right? If you cannot store more data in your system, what will you do? You will put it into hard disk, isn't it? So likewise, you can store the data in the cloud. Cloud gives different types of services, like platform has a service, infrastructure has a service, software has a service. It provides different types of service. So Internet of Things is mainly related to cloud. With the cloud, only we can work on Internet of Things. So you should know how to send the data from your system to cloud and access the data from cloud to your system. So I'll be showing the demonstration of this later. So there are different types of clouds, AWS clouds, Meta Cloud, Google Apps, WebEx, Salesforce. There are different types of clouds available. And it is up to you which cloud you want to use based on the services given by the cloud. And don't think that you have to pay a lot of amount to use the cloud for your project. It is just 20 rupees or 30 rupees you need to pay using your credit card. It comes for 1 year. You can use it for 1 year. Okay. Actually, one batch students, they use the cloud like this. They used Amazon Cloud. They just paid 20 rupees using their credit card for whole year, so that they were able to demonstrate the project in the exam. Okay, this was possible. So next, there are different types of apps that are present in this Google Cloud. Taking as an example, we have Gmail, Play Store, Google Drive, all those. So we can use it. Okay, so cloud computing. So what is this cloud computing? Basically, we cannot compute everything in our system. There are some algorithms and programs which are required. And what you can do is you can send them to cloud and get the computing done in the cloud, and later you can get it back. So you can rent the cloud. You can rent some services in the cloud. Suppose you want a server. Instead of buying the server for yourself, you can rent the server service given by the cloud. So like that, it gives different types of services, like storage has a service, and platform has a service, infrastructure has a service. So we can make use of the cloud like this. And the benefits of cloud computing is the cost becomes less, the speed is high, and it is global scale, productivity is more, performance is more, and reliability is more. Suppose if you store something in cloud, it won't be lost. It will be there permanently, right? Unless you remove it, right? So how to start projects? So how to start projects? So this is the big question, right? So it's not that difficult to start the projects. I'll show you. So what we require to start projects is we require Arduino board, Raspberry Pi, sensors, breadboard, internet, and connecting wires. We require all this: Arduino board, Raspberry Pi, sensors, breadboard, internet, connecting wires. Only these basic components are required, but there are Other components like node MCU is required. Suppose you want to connect it to a Wi-Fi network and all. There are other components which are required, but the main important things which are required to do the project I am exhibiting here. So this is the Arduino board. This is how it looks. So I have a Arduino board here. One second, I'm showing it. Yeah. Are you able to see me here? I'm showing the Arduino board. Are you able to see me?
Yes, ma'am, it's visible.
Yeah. So this is the Arduino board. In the Arduino board, we have microcontroller. This microcontroller board, it is at Mega 328p, and we have pins, input output pins. There are 14 digital input output pins and 6 analog inputs. So here you can see I have A0, A1, A2, A3, A4, A5. Okay, and here I have digital pins D0, D1, D2, D3, D4, D5, D6 to D13. Okay, and here I have a USB connection, and then here I have a power in button. Okay, so this is the ICSP header, and then I have a reset button here. Sometimes I need to refresh the contents present in the microcontroller, so I have a refresh button. So I have a USB connection, a power jack. So a power jack is given here, okay, to power it up. And then next I have a microcontroller. On this microcontroller, we are loading the program. The program is basically loaded on the microcontroller. When we dump the program into microcontroller, we can make this Arduino Uno to work according to whatever the program you have dumped into microcontroller. I hope you're understanding the point. Okay. So, and we have 16 megahertz ceramic resonator. Here we have 16 megahertz ceramic resonator. So this 16 megahertz ceramic resonator, it represents the clock pulse at which this Arduino Uno works. Okay. So, and this Arduino board is available online, and if you're buying online, it would cost around 450 to 500 rupees. There are different types of Arduino boards. We are using Arduino Uno board. Okay.
Ma'am, sorry to interrupt. We couldn't see your Arduino board.
Are you not able to see this board?
No, ma'am.
1 second. I'll just check this. Now?
No, ma'am.
No, ma'am.
1 second. ನೀನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ, ನಿನ್ನೆ ಇತ್ತಲ್ಲ ಆ ತರ, ಯಾಕೆ ಈ ಕಡೆ ಬರ್ತಾ ಇಲ್ಲ? 1 second. I don't know why it is not. Can you see now?
Yes, ma'am.
Yeah,
Yes,
sorry, there was some interruption. So this is the Arduino board. Okay, this is the Arduino board. In the Arduino board, we have a microcontroller. We have microcontroller and we have digital inputs and analog inputs. So here the program is dumped into 80 mega 328 microcontroller. So what it works based on whichever the program we load it into 80 mega 328 microcontroller. And we have analog input. Sometimes the sensors what we use, they take analog inputs, and sometimes we give digital inputs. So to facilitate both analog inputs and digital inputs, we have both. Okay. So this is the Arduino board. Actually, we use this Arduino Uno board for doing projects, and we have USB input and we have power input here, and we have 16 megahertz which provides clock. It should work on clock. Any digital equipment should work on clock, right? So we have this here. Okay. Okay. So this is the pinout diagram. This is the pinout diagram of Arduino Uno. This is how it basically looks. So don't feel tough, like it is very tough to understand. It's very simple. So coming to the sensors, that is, a sensor is a device that produces an output signal for the purpose of sensing of a physical phenomenon. And here we have different types of sensors. Actually, we have different types of sensors. We have color sensor, rain sensor, PIR sensor, gas sensor. So many sensors are there. Okay. We are going to demonstrate using some of the sensors. And examples, see, we have LDR. We have solar lights you have seen in the roads, right? Nobody goes there and switches off the street light in the evening, or switches off the street light in morning. Nobody will switch on in the evening or switch off in the morning. So we have automatic switch on and switch off lights. How they work? The thing is, we have solar panels. With the help of solar panels, it will get charged. Okay. Then in the night, we are going to get the light out of it. But how will it understand that it is dark and the light should be made on? How will it understand? How the system will understand? So for that, we have LDR. I'm going to show now how it works. For that, we have LDR. So LDR, it makes the light to switch on when it is dark. It senses the darkness. Okay. And then when there is no light, it automatically switches on the solar light. Okay. So that is what we use in our street lights. So, and basically we need connecting devices. That is, we have breadboard. Breadboard is very important. You have to understand the breadboard first. Without understanding the breadboard, you cannot connect. And here we have a serial connection, and here we have parallel connections. So I can say you have to consider the serial connection here. That is row wise. You have to consider the row. The rows are internally connected. Here the columns are internally connected. Okay. If you don't understand this concept, you cannot simply connect. So Breadboard, it is a prototype board where you can make connections. You can construct your IoT work with breadboards. Okay, so you should know the construction, how it should be, and you have to make connections over it. Okay, then we need jumper wires. There are 3 types of jumper wires, that is male to female, female to female, male to male. There are different types of jumper wires. Actually, I have jumper wires here. These jumper wires are, you can see here, that is, you have pins at both the ends. So you have pins at both the ends. This one. So these are, you have pins at both the ends. So it is male to male. And here I have jumper wires. This is female to female. And then this is male to female. So these are the different types of jumper wires that are available, and using these jumper wires, you are going to connect Arduino board to breadboard and so on. Okay, depending upon the type of connections. So here we have Arduino board, and the next comes the applications of Arduino. That is what you can see some more applications here: weighing machines, traffic light count, parking lot counter, embedded system, home automation, industrial automation, medical instrument, emergency light for railways. So all of you can come out with some of the projects. These are some of the examples of the projects you can come out of it. So how to install Arduino IDE, right? To make this Arduino work, you need to install Arduino IDE. How to install Arduino IDE? So I'll just show you. Yeah. So you can install Arduino IDE. So what is this Arduino IDE? Many of you are beginners are here. So you need to install some editor screen, some IDE to make your program work. For example, you have done in your first year, that is you use Turbo C to make your program work, or on Linux platform, you made your program work, right? Like that, you need some background or some interface where you can make the program run. Okay. So for that, you need to go to Arduino, go to Google and type Arduino for Windows 10. Go to Google. Are you able to see the screen?
Yes, ma'am, your screen is visible.
Go for Arduino for Windows. So then you can see here software Arduino, right? Software Arduino. Click over that. And you will go to arduino.cc. We'll go to arduino.cc. In arduino.cc, you come down like this, and you can download options. In download options, you have Windows. Okay, click over Windows. So it is open source. It is available for free. You need not pay anything. Just download. Click on just download like this. So you can see that Arduino is downloading, and then the software is downloading. You will get an executable file once it downloads. So then you go there and install. Okay. Up to here, is it clear? So go to Google.
Yes, ma'am.
You have to give Arduino for Windows 10, and then you will get that Arduino software. Download it. It will download, and later on procedure, you know that you have to extract the files, and you can keep a shortcut on your desktop. Okay, so you can easily do it. It takes just 5 minutes to download, and it is open source. You need not pay anything for it. You know the meaning of open source, right? It's freely available. Any platform, any software which is freely available, and you also can contribute to that. That makes open source. Okay. So now I have already installed it. I have it on my desktop. I'll show you. See, I'll share the screen. Yeah, I have already installed. Once I install, I can download the other programs. So I have this like this. So I have a code here. So I can open it. Yeah. So this is how the editor screen for Arduino looks. We have file, edit, sketch, tools, help.
Mom, it's not visible.
1 second. Yeah, now is it visible?
Yes, ma'am.
So we have editor screen over here where you can type the program, and we have a file, edit, sketch, tools, help. So you are going to type the programs here. In file, we have preferences option. When you click on preferences, you can see the settings like this. So it shows the sketchbook location, and it shows the additional boards manager. So suppose you are using Node MCU, you need this. You have to download the package for additional boards. So I'm using Node MCU later. So I have taken the link. I need that link and I have installed that library. So other than Arduino board, if you are using any other boards, you need to use this URL. Okay, additional boards manager URLs, you need to use it. Okay, to support them to work. Okay. So then we have edit, sketch. So the program what we write here is called sketch. So as we compile the program in other programming languages, we compare here also. We use C++ programming language. Okay. So let us see how we can make a program to work using this Arduino screen. Okay. I have Arduino board. I have an Arduino board connected to LED. Okay, so I will make this LED blink. So I want to power on this. How to power on this? We get a cable. We get a cable to power on this. So this is the cable available. For different types of boards, we have different types of cables. Okay, so we have this cable, this particular kind of cable to connect it. Okay, so I am connecting the Arduino board to it. So I told you we already have this part. We already have this part where I can connect. So I am connecting it over here. I'm connecting it over here. And why I'm doing this? Because I need to power it on. I need to power it on. I'm showing this. I hope you can see. I'm trying my level best to show here. So this one, the another wire, you need to connect it to the laptop. You can take the power from it. So now you can see the LED, LED in the Arduino is on. The LED in the Arduino is on. So when you just see a slot in your laptop, you can connect it to your laptop, or you can connect it to your CPU also. If you have a desktop monitor, you can connect it to CPU. If you don't have desktop monitor, you can connect it to laptop. So why I have connected this? To give power to the Arduino. So I have taken that cable and I've connected it. It's very simple. You can take the power from laptop itself. So you can see the LED blinking. So this is the example for serial communication. That is, I am sending the data from laptop to Arduino board, right? That is serial communication. So as soon as I connect, this TX RX pins, which stands for serial communication, will switch on. Okay. And I have connected LED. So how I have connected this LED, I'll show you. This is the breadboard. This is the breadboard. The breadboard, I told that this one, it stands for ground. The red color, you can use it for VCC, and blue color, you can use it for ground, both the sides. And they are internally connected row wise. And here they are internally connected column wise. That means the values are same in the same column. Okay. And you can see division over here also. Okay. That means this part is different and this part is different. Okay. So you can make the LED glow. How you can make the LED glow? We'll see. I have used this breadboard, and you know that the LED has anode and cathode. The LED has anode. This is anode and this is cathode. So anode and cathode. So for anode, I am giving input from pin number 13. I'm giving input from pin number 13. And cathode, I'm connecting it to ground. Okay. So while giving input, I have used a resistor, 1 kilo ohm resistor I have used, so that any fluctuation in the input voltage should not spoil the LED. So the voltage should be proper in order to not to spoil the LED. It is a very simple connection. I'll show you how to connect this in the PPT. This is the connection. So what I have to do is, we have some set of programs in Arduino only. So I'll go to File. I have examples here. Okay. And select examples and come to basics. In the basics, I have blink. You can see blink. This blink program is for blinking the LED. Okay. Once you get that program, you can verify the code by clicking on this, verify. Okay. So your code is verified. You can see the code is compiling here, compiling the sketch.
Not seen, ma'am.
You can't see? Down. Are you not able to see?
Yes, screen is stuck, ma'am.
Screen is
Frozen, ma'am.
frozen. 1 second. Now, maybe due to internet problem. Now, is it fine? Can you see?
Yes, ma'am.
No. 1 second. Pause, share, resume share. Now,
Oh, ma'am.
can you see the Arduino editor screen?
Yeah, ma'am. Yes, ma'am.
You can see Arduino editor screen. So in Arduino editor screen, go to File. I'll come once again from beginning. Go to Examples. Okay. And go to Basics. You have some set of programs in the IDE itself. So here in Basics, I have Blink program. So when you click on that, you will get the program. Can you see the program?
Yes, ma'am.
Yeah, ma'am, we can see.
Yes, ma'am. The program is visible.
So this is the program. Okay. So you have to verify it. That is, when you run C program, you will compile it, right? So like that, we need to verify. So the program what we write in Arduino board is called sketch. The word is sketch. So verify. So verify means you are compiling. Can you see compiling at the bottom? Compiling the sketch. Yeah, it shows done compiling. Okay, it shows done compiling, and then next it shows done compiling, and then you have to upload. Upload, it makes your program to be loaded into the microcontroller. It makes your program to be loaded into microcontroller. Okay, so once it is loaded, you can see, one second, I'll turn on the So it's very simple connection. I have taken an Arduino board. I have connected here. Okay. So then I've taken from 13 pin. 13 pin is inbuilt LED for Arduino. Okay. And then I have VCC connection. Okay. And then I'm connecting this to ground. It is simple connection. So now you can see the LED is glowing. It's very simple. Now you can see the LED glowing. It is blinking, right? See, it is blinking. So what I did, I have connected pin number 13 to anode through resistor. Why I have connected through resistor? So that the LED should be safe. 1 kilo ohm resistor. Then cathode to ground. So you can see this black wire, this is ground. Okay, the black wire is ground. And how to connect ground? You take a ground. There is a ground connection in Arduino board, G and D. From there you can connect. Okay. So this is how it is connected. And let me show the code here. Yeah. You can see the code over here. That is void setup. It's basic C++ programming. Void setup. You are going to set up all these things, that you are going to initialize all these things. So pin mode, these are all keywords. The ones which are in red color, they're all keywords. So LED built in and output. Then digital write, like how you are going to use a scanf and printf. So for Arduino boards, we use digital write. So digital write is high, means turn the LED on. Okay, and wait for a second. So it turns on the LED, it waits for a second, and then it turns off the LED. Okay. So this is the basic program. So this is in loop because it continuously keeps in the switch on mode and switch off mode itself. Okay. So we are putting it in the loop. So that is why it is continuously switching on and switching off. So this is a basic example. So like this, we have so many examples here. Basics in that analog, read serial, bare minimum, blink. You can try all this. So the beginners can start with all this. Using button, using switch, analog and all. We have so many inbuilt programs that are available. Sensors, using sensors and all. So you can start with some basics which are available in this Arduino only, Arduino Ide only. So it is not at all tough. You should have a Arduino board, breadboard, LED, jumper wires, and then you can connect it. So this is the basic program. This is the first program which could be demonstrated. Okay. So I hope you understood. Any doubts in this? Okay, so this is the blink LED. Then we have ultrasonic sensor. Ultrasonic sensor, it basically works on the ultrasonic waves. You can see there are two inputs. One emits the ultrasonic waves and the other receives the ultrasonic waves. That is, when the ultrasonic waves are emitted, it goes and it bounces back. It hits some wall or something like that obstacle and it comes back. Okay. So there we use ultrasonic sensors. So we use ultrasonic sensors. So our students have done projects on this ultrasonic sensor. We are going to demonstrate it shortly. So here we have ultrasonic sensor, how we can connect it to the Arduino board that can be shown in the diagram. And the ultrasonic sensor code is written here. Again, it is a C++ code. If you are good at C++, you can write code. All embedded system programmers, they need to know C++ very well. You know what are embedded systems, right? How your washing machine works, how your microwave oven works. You can set the time and make them work for a fixed amount of time, right? You can set the time for your oven to work, say for 20 minutes, 10 minutes, or your washing machine, right? So all these things are possible because of the embedded systems which work mainly on these concepts. Okay, programming. The ICs are programmed. We are writing the program on ICs using C++ programming skills. Then coming to the Node MCU. So Node MCU, it is required for connecting it to internet, cloud. How do you connect your board, Arduino board, to internet? So you cannot connect Arduino board directly to internet. You need to attach a Wi-Fi module or internet module. So instead of that, I can have here, a Node MCU, which can be connected to the internet. Okay. So Node MCU, it is a low cost open source IoT platform. So the name Node MCU, it means Node Microcontroller Unit. So it's a firmware, and firmware is the one which helps in programming as well as connecting it to the network. Okay, it's a hardware connectivity. It helps in hardware connectivity. So in computing, firmware is a specific class of computer software that provides the low level of control for devices specific hardware. Okay, so we shall see how we can use Node MCUs also. I'll show you some demonstration on that. So one more thing I want to show, LDR, right? When it is dark, the light glows. When it is bright, the light switches off. So I will show that program also. I have made, stop sharing. One second, I'll share the screen. So I have a code here for LDR. Okay. Can you observe the code? Can you
No, the screen is not shared.
one second. Yeah, can you observe the code now?
Yes, ma'am.
Yes. So here also we have C++ programming. So LED pin 13 and LDR pin A0. Here you can observe we are using analog input. Analog, some waves, some signals or analog signals that is taken as input. Okay. So this is A0. In your Arduino board, you have provision for taking analog inputs also, not only digital. Okay, so void setup. So we have serial.begin. This is 9600. So what is this 9600? It is baud rate. Usually your Arduino boards work with 9600 baud rate. That means what I can say in simple terms, frequency. Okay, or different levels which it can go up to, that is 9600. And remember everything here, if I mention time, it will be in terms of milliseconds. Okay. So we have pin mode, LED pin output, pin mode, LED pin input. So we have a void loop here to make the LED glow when the LDR senses it is dark. Okay. So this is how I can write the code. If LDR is less than, I can set this value to anything, say 200 or 300 based on this, that is intensity of light, luminescence value. So then digital write, LED pin high, then serial dot print, it's dark, turn on the LED. Okay, it's bright, turn off the LED. So I'll just show you how to work with LDR. It is very simple. You need Arduino board again, breadboard. You need to make the connections. I show you here. Once again, I'm getting it. Here you can see LDR. Can you see LDR here? This is LDR. LDR. So the connections, I have made serial connections here. So again, I have used LED to switch on or off. Okay. I'm going to connect this Arduino board to this. This very simple connection. I'll explain the connections using the circuit diagram. But this is how I have connected. I have used a LDR. You can see LDR here. Well, if you can see the LDR.
Yes, ma'am.
Yeah. So I think third semester students have come across this in module 1, isn't it? Yeah. Okay. So now we shall dump the code. So how to dump the code? Have to verify. Right? So verify is compiling the sketch. So every time when you verify, your program will be compiled. And then when you upload, the program will be dumped into your microcontroller. So it is compiling. You can see at the bottom. Can you see?
Yes.
Yeah, it is compiling. These experiments you can start at your home. You just need an Arduino board, a breadboard, LED wires. So it gives some confidence for you to start projects. These are the basic things which are required. Suppose you want to use the LDR in your project, you can use it easily. So compiling, it takes time. It is compiling, just few seconds. Now, then it shows done compiling. Can you see here? There are no errors in the code. It shows done compiling. And then I am uploading it. Yeah. So once I upload, I'll show this connections. 1 second. Where was I? Here, yeah. Ultrasonic sensors. Okay. So once I upload here, see here, if I keep my finger on LED, the light glows. Sorry, on LDR, the LED glows. Can you observe?
Yes,
I'll
ma'am.
remove my finger. It slowly switches off. That means when I make dark, when I make this dark, the LED glows. When I remove my hand, the LED switches off. Why? Because there is bright sunlight. When sunlight is there, the LED switches off. When I close this, the LED switches on. When you can experiment this, see, it's switched off. This one you can see here. In the serial monitor output, you can see this in the serial monitor output. This is called serial monitor. Like how you see the C program output and all, you can see the output in the serial monitor.
Excuse me, ma'am.
Yeah.
Ma'am, just a gentle reminder, at 11:30 we'll have a short break.
Okay. Okay. I'll
Okay.
complete this experiment.
Yeah. Thank you, ma'am.
Yeah. So these circuit connections are very simple. By the time it uploads, I'll explain the circuit connections. So if you start working, you can easily do it. Sometimes you can see the board at COM7 is not available. Such type of errors is common. Can you see this error? Board at COM7 is not available. We know that we use ports to communicate, right? So for that, you have to go to tools, okay? And you come down here. Are you able to see the screen? Yeah. So here, you come down, select the port COM3. See, our system, any computing system has ports to communicate, right? So here we have ports to communicate. So this Arduino board is making use of the port COM3. It has given the name as COM3 to communicate. In all your systems, you will be having this. Okay. So just check it. Check it means select it. So go to tools, come down, go to port. You can see here Arduino Uno and then select the COM3. So then only you can work with that properly. Otherwise, communication will not happen between your system to Arduino. The basic thing is you're loading the program from your system to Arduino board, isn't it? So select it and leave it. So observe that I have put check mark here. It is very important. After doing that, again come back, verify. You have to select the port through which you are communicating. That is very important. So compile the sketch. Done compiling and then upload. Upload is you're dumping the program to microcontroller. Okay. So once it is uploaded, here you can see the TXRX pin starts blinking. Okay. So then you can come to see here, you can see the display, how it is coming. If I keep my finger on the LDR, it is showing it is dark, turn on LED. Can you observe it? It is in the serial monitor. You have to, on the top right, we have serial monitor. You can see the results in serial monitor. Are you able to see?
No, ma'am.
Serial monitor. It is dark,
ma'am.
turn on the LED. Are you not able to see? 1 second. Yeah. Now can you see?
Yes, ma'am.
See how it is coming. You have to do this much. You have to go to the top right. There you click. There is serial monitor. You can see results in serial monitor also. So now I have lifted my finger from LDR. So what it is showing now? It's bright. Turn off the LED. And this is luminescence value. What it is showing is 323, 343, 356 and all the value. Okay. So now I'll keep my finger over it. So it becomes dark for it. So it says it's dark, turn on the LED. The LED is on. It's a very simple concept, what we use in our lights, street lights, solar powered street lights. We can use this. See, they are making use of solar energy as well as they're making use of this LDR. So we can save electricity, right? So you can use this as a part of your project, isn't it? You can make a dark room and you can make the LED glow. Switch on the light. And see, I'm working with just LEDs here. You can work with bulbs also using relays. Okay, like bulbs, how we use in our home. You can use with bulbs. The same concept. Okay, so circuit connection. It's very simple. We have LDR. We have LDR. So LDR has two legs. One leg is connected to, obviously, the pin number 13. Always remember, pin number 13 is a built-in LED. Okay, for that. So then we have, the anode. Anode of this LED is connected to pin number 13. Cathode is connected to ground. Always remember, anode connected to LED. Anode is connected to pin number 13 and cathode is connected to pin number, here it is 14 here. So ground, it will be mentioned G and D here on the Arduino board. It will be mentioned as G and D. So connect the cathode to G and D, anode to pin number 13. And we have this LDR. LDR has two legs. One leg is connected to analog input. We are making use of A0. In the previous experiment where I made the LED glow, I made use of digital input. But here, since the signals, light signals, it is using light waves, right? Light signals or light waves. It is in the analog form. So I have to use A0 in Arduino board, A0 or A1 or A2. So whichever the pin you use here, that should be mentioned in the program. So in the program, I have mentioned in the beginning that pin number 13. Why is this pin number 13 is there? Pin number 13. Please be interactive. Pin number 13 is connected to
the internal LED present in the Arduino.
Yeah, and Arduino has a built-in LED here. This thing is projected here. That's it. The same LED what we have here is projected here on the breadboard. So whenever communication happens, this TX RX pins, they blink. Means it shows that it is the data is moving from your system to Arduino board. If they don't blink, when you run the code, if they don't blink, the TX RX pins here on the Arduino board, if they don't blink, that means your program is not loading to your Arduino board. There is some problem in the board or your port. It should blink. Okay. And then I'm specifying A0. Why I have specified A0? Because one leg of LDR is connected to A0 in the Arduino board. So like C programming, you have to mention how it is connected and all, it has to be mentioned. So serial dot begin, it's a programming concept what we use in Arduino boards. So LED pin output pin mode, you have to mention. These are all keywords. Okay. So then this value I have given luminescence value. I have kept less than equal to 200. Brightness, usually we keep it this much. So then this, digital write, where are we writing? LED pin, using the LED pin data and high. Okay. Then serial dot print, it's dark, turn on the LED. Serial dot print ln, new line. ln is new line. So LDR status, then digital write, LED pin low. Okay. So I think you feel it as a new language. So don't worry, it is C++ only. It is this type of keywords you might have not used before, that is serial.print, digital write, all those things. So you're new to it, but once you start programming, it will be easy for you. Don't worry, it is very easy for you. Almost all programs are similar. Only thing is you have to change the pin numbers which you use. You should be very, very cautious in this. If you don't change the pin numbers and if you start working, you will not get the result, because some pin you have connected, some pin you are showing in the program, it won't work. So it should match the pin numbers which you are connecting here and pin numbers which are mentioned here, they should match. Okay. So I think you understood this concept. So we shall have a tea break for some 10 minutes. After that, we will send data to cloud and take the data from cloud. I'll show you how to send data to cloud and take it from cloud. We'll start using cloud. Okay. So after 10 minutes break, we will come back. Any doubt?
Ma'am, I guess there are a few people waiting in the waiting room.
Okay. So I know I cannot make you understand complete 100% because it is online. I have that guilt, but try to understand something and you try to come up with some small projects. If you have any doubts, you can come to me in college. You can meet me. I'll help you out. Okay. Yeah, shall we have a break? Yeah, for 10 minutes, 10 to 15 minutes. If you are trying the experiments which I'm showing, some of you might be trying, you can try it. If you have any doubts, you can ask. Programming, don't worry, you will slowly get along with that. This is how embedded systems are programmed. These are the basics. Okay. Okay, we'll meet.
Excuse me, ma'am.
Yeah.
There are a few people waiting in the waiting room.
Waiting. I admitted them, but
they weren't able to join.
Oh, okay. So anyways, it is tea break now. I Harshita as host. Harshita can't admit. Okay, I'll just check it out. Okay.
Yeah, they got disconnected in between, ma'am.
Oh, okay. So they can join in another 10 minutes.
Okay, sure, ma'am.
Thank you all for being patient and listening to my words or experiments, what I'm showing. So I want to make it still more interesting after tea break. So we'll join after short break by 11:40. Okay, thank you.
Hello guys, the certificates would be issued only to those who are attending the entire event and would be filling the feedback form. So make sure you attend the whole event if you want certificates. Yeah, now you could go for a break. At 11:40 we can come back and restart the session. Yeah, don't worry. The feedback forms will be sent to you after the event ends around 3:45. Meanwhile, if anyone has any doubts, whatever Ma'am has taught so far, you could just put in the chat box or you can unmute yourself and ask. Yeah, I think a student has a doubt. Will all examples shown by ma'am be ones found inside Arduino itself? No, a few examples are demonstrated by ma'am. So if you want a note of those, you could ask ma'am to share those. We would be doing that as well. Also, guys, whoever has answered yes, if you want to demonstrate your projects in IoT in this particular workshop, and you want to, yeah, feedback form will be shared in the comment section, and it won't be shared in the WhatsApp group. It will be shared only in the Zoom comment section. Yeah, if you guys want to demonstrate your projects in this workshop, it is a great opportunity, guys. If you wish to do that, you can just ping the admins in the IoT workshop groups, or you could ping even in the chat box here. We would also get ready with the equipments if you want to demonstrate your projects. Yes, we would be putting the feedback form link even in the YouTube comment section. Do not worry about that. Guys, I'd like to say that don't miss the opportunity. You can share your knowledge with the co-participants here and let them know about your knowledge in IoT. So if you really wish to demonstrate your projects, you're always welcome. Okay, Harsh, Abhishek, you want to demonstrate your projects, right? You could ping the admins in the IoT workshop group. They would be listing down the names there. Ashwini, what will be the next session timings? We would be starting in a minute or two. We would be Smita S would be giving the introduction to IEEE, and then Shalini ma'am would continue with the concepts related to IoT. After lunch, we would be having the demonstration by seniors and alumni of AMC Engineering College. I hope this clears your doubt, Ashwini. Okay, great. Yeah, if anyone else has any doubts you want to ask Shalini ma'am, or any doubts related to the event or your project demonstration, you could you feel free to put in the chat box, or you can text the admins also. Hello, We would be restarting the session in 5 more minutes, guys. Thank you for your patience. We now have Smita S. She would be introducing you to IEEE and the events under IEEE, Student Chapter, AMC Engineering College.
Harshita, many participants are still waiting in the lobby.
Yes, Meghna, just give me 2 minutes. I'll let them in.
Yeah, sure.
Yeah, I think they were let in. All the participants who were in the waiting room. Harsh, if you are attending the entire event and filling the feedback form, yes, you'll receive the certificate. And like our team said, anyone who wants to demonstrate your projects and you are confident enough that you can demonstrate your project, you will get your certificate of appreciation as well. Do not worry. Yes, certificates will be sent to the respective mail IDs which you filled in the form. Yeah, those who are demonstrating your projects, make sure you're ready by 3:15. We would be wrapping up with the seniors demonstration by 3:15. You can start asking your queries to Shalini ma'am or our student members, and you can also get ready with your project demonstration. Anyone else who's interested in demonstrating your projects or showcasing your IoT hobby projects, you can go on and text the domains admins in the group and you can demonstrate your projects. Yes, Mita, I think you can start now. Smita, are you there?
Are there?
Okay.
My voice audible?
Yes, Mita, yes, you can go on.
Greetings of the day, everybody who's present there. I'm Smita, and I'll be briefing you about the IEEE student branch. IEEE is a global organization that allows students of all branches to come together by using technology to help humanity. By joining us, you can be a part of a community where you can gain knowledge about the most recent technology and gain access to many information sources. Not just that, but you can also let your thoughts be heard and help organize events within your college. Here in AMCEC, we have conducted many events. We started this SEM with a LinkedIn profile building and resume writing workshop. The speaker, Ms. Shruti Goyal, a renowned resume critic, gave a depth details on how we have to work on building our resumes and profile on LinkedIn. This is followed by a webinar which was conducted by the EC department, wherein our own speaker was Dr. Janita J, the IEEE student branch counselor, gave a detail how to give a flow in a research paper as such. Under IEEE, the EC department also conducted a poster presentation event. By all these means, by joining this IEEE community, you will gain access to IEEE Explore Digital Library. Now, what is this digital library? Well, it is nothing but a research database where you can discover and have access to journal articles, conference proceedings, materials related to engineering fields, and so much more. You will also get a subscription to IEEE Potentials magazines dedicated to undergraduates, graduates, and young professions. Here you can have articles to be published globally. IEEE is a place where you can do projects and meet people of diverse background. Want to join this global community to bring some changes? Well, fill in the Google form that will be shared later by Harshita.
Yeah, thank you so much, Smita. Yes, guys, if you're interested to join the student branch in AMC Engineering College, if you're a student in AMC Engineering College, to be more specific, we would be sharing the feedback form. You could enter your details there. Our team would reach out to you.
Yeah, Harshita, can we start?
Just a minute, ma'am.
Yeah.
Just a minute, ma'am. I'm just admitting people.
Yeah. Let them come. We'll wait for 5 minutes.
Okay, ma'am. Yes, guys. Meanwhile, if you want to ask ma'am any question or query or anything that you didn't understand in the previous session, you can go ahead and ask ma'am doubts. Guys, those asking for the feedback form, do not worry, we'll not be sharing it now. We'll be sharing it towards the end of the session, around 3:45. You could fill the feedback form then.
Yeah, what I personally feel is all of you have to become members of IEEE student group. It is very innovative group, and you become member for IEEE also. IEEE Explore and all will be flooded with so many new concepts, so many new technologies, and you become entirely a different person. You become entirely a different person. And I think you have to subscribe for some magazines, say open source magazine, which is monthly subscription. You will come to know what are the recent technologies, developments that are happening in the field of engineering and technology. I think many good students are here, meritorious students are here. You have scored 8 CGPA, 9 CGPA, 10 CGPA also, right? So nowadays, marks won't work. The knowledge works. How much knowledge you have, the skills work. See, imagine so many students are there, right? Engineering students are there. So many students might have secured the same CGPA what you have secured. In what way you are different, right? It matters. You have to enhance your skills. You have to do more projects. One project teaches you so many skills. If you jump into a project, it teaches you so many skills. Like it can teach you programming language. Yes or no? Let us have interactive section. So it teaches you programming language. You will
guys, yeah, please interact with ma'am.
Yeah, you learn new programming language. You will learn about a board, Arduino board, how it works. You learn about the basic connection concepts on breadboard, how to connect LEDs, LDR and all. Right? So many things you learn. One project makes you learn so many things. See, I have done a very small project, a small thing, small experiment, I can say. Here only, there are so many things to learn. You can learn about Arduino board, how it works. You can learn about the microcontroller in this. You can learn about the circuit connections. You can learn about LDR. You can learn about the C++ language, which you are going to write there. So it enhances your knowledge. You start doing a project. You make like this. 1 week or for 1 fortnight, one project you're going to do. Make groups among yourself, teams. Each of them will be good in something. Like one will be good in connections, someone will be good in boards, someone will be good in programming. Yeah, let them contribute. Make a project out of it. So unless you start doing projects from your earlier years, you cannot suddenly jump into a project in final year. I think the definition of project only you will not be understanding at that time, suddenly if you jump. So start doing projects. Project enhance your skills. It makes you learn more and more and more. Nowadays, it's of no use if you secure CGPA like 9 CGPA, 10 CGPA. I'm not degrading that. But along with that, it's good that you have that much CGPA. It's very good. But along with that, you should have enhanced skills. In which area you are proficient? If somebody asks, in which area you are proficient, what would you say? I've not done anything. Will you answer like this? No. Some of my students, they got placed in Tech Mahindra because they knew the concept of using cloud in their project. They did in-house project and they would able to send data to cloud and retrieve the data because they knew the knowledge of cloud they could get. Okay. And one more batch student, they got recruited because they knew the knowledge of networking, how to send packets, receive packets, how to observe the tables and all. So I have done many research projects also with my students. They enjoy doing projects. See, first you should have that mindset. You should enjoy doing projects. Yeah, it is not that easy. You will have a lot of hurdles. You will lose patience. You will get exhausted. You will get frustrated in between. You should not leave. That should be your mindset. You should have a lot of patience to do in-house project. It's not that easy. It's not a cakewalk. Got it? But what you gain out of it, it is more than what I can say diamond mine. It is more than a diamond mine. And you feel happy to keep working more and more and more on these projects. If I want to tell you, sometimes I work till 2:30 a.m. in night on these projects. If I start doing it after dinner, if I start, I don't know, the time runs. Till 2:30, 3 o'clock I'll be doing, or then I see the clock, oh, it's already 2 o'clock, then I'll go and sleep because I have to wake up and come to college in the morning. So that's the thing. So it will, once you jump into it, it will take you like in the flow, it will take you. It's like, I love to do all these projects. Okay. So you make it as a hobby thing. Whenever you are free, weekends, Saturdays, Sundays, instead of going to movies or go to movies, okay, that should be there. Instead of wasting time, seeing some junk things and doing some junk stuff, use your time for this. It gives you happiness, really.
Definitely. Thank you so much, ma'am. I'm sure your words will inspire a lot of students out here and they will start on their projects in various domains. Thank you so much. Yes, guys, I think we can start with the next part of the session. Before that, I would just like to give a brief introduction about our resource person for today, Professor Shalini. Yes. Ma'am is the assistant professor in the Department of CSC, AMC Engineering College. She is currently pursuing her PhD at MSRIT under VTU. Ma'am has also published papers in elite conferences and journals. She has conducted various workshops, mainly in the domain of IoT, to motivate students to start with in-house research projects. Ma'am and her students have received KSCST funds for in-house projects in the years 2019-20 and 2020-21. Thank you so much for being here, ma'am. We are more than happy to have you as the resource person for today's event.
I'm very fortunate to have your team. You're all really hardworking. I like your ambitions.
Thank you so much, ma'am.
Yeah. Okay, I'll start over now.
Yes, ma'am, sure.
Yeah.
Guys, your doubts regarding IEEE student membership fees, it would be resolved during the last part of the session. Do not worry. Yes, ma'am, we can continue.
Yeah, still people are joining. So please don't lose interest, be patient. So those who attend completely will be given certificates. It's the rule that is formed by IEEE chapter. So kindly attend, attendance matters. And I'm not forcing anyone, but interest. If you have interest, you attend. Yeah, I was talking about cloud, right? So till now you saw the working of LED, blink. Then you saw how the LDR works, right? But taking these values, what you can do taking these values? You need to store somewhere. You saw that LED results that was coming in the serial monitor. You should put it somewhere. Yes or no? Where to put it? You can store it in your computer, but how long? How many days you can store? It will be overflow, right? So what will you do then? You need cloud. You need to cloud to store the data. Without cloud, you cannot store elsewhere. Of course, you can store part of it, but not like continuous. Suppose you want to know the weather of Bangalore in the month of December. So how you can say like it is very cold weather? How you can say? How you can come to conclusion? You cannot simply come to a conclusion like that. You have to find out December 1st, what was the weather? December 2nd, what was the weather? December 3rd, what was the weather? And along with that, you should note down the temperature values. What was the temperature in the morning? What was the temperature in the afternoon, evening, night, right? So finally, you can come to some conclusion. Oh, December is a very cold month. The weather is very chill in that month. So you cannot simply come to conclusions like that. So using the sensors, with the help of technology, you can analyze. That is what is called analytics, data analytics. That is the buzzing topic right now. So it's a very important concept now, data analytics. They take data from sensors, they put it onto cloud and analyze it. So that is data analytics. Though it is of 2 words, it has a lot of meaning in it. Okay? They are highly paid jobs. The data analysts are they're highly paid. Okay? So we'll see what technology helps us in sending data to cloud. So I was talking about Node MCU. Still people are joining, I'll admit all. Okay. So Node MCU I have here, I'll show you. This is Node MCU. This is Node MCU. Okay. So this is also a microcontroller where you can connect it to internet. It is available in online shopping. You can get it from Amazon also, you can get it. So this is Node MCU. Here you can see the cloud symbol is there. It shows that you can connect it to cloud. Okay. So it is basically a microcontroller with the network connectivity. You can say it as a firmware. It's a firmware. Then we need a cloud. I showed you so many cloud in the beginning. Microsoft Azure is a cloud. Amazon Web Services is a cloud. Google Cloud. There are so many clouds. We are using one such cloud, that is Thinkspeak. Are you able to see the screen?
Yes, ma'am, your screen is visible.
Yeah. This is the cloud we are using for our projects as of now. You can use other clouds also. Just as an example, I have taken this Thinkspeak Cloud. So when you Google it, you can see this. So I'll show you how to go here. Can you see the screen now?
Yes, ma'am.
Yes. So here you just type Thinkspeak. I have already typed many times, so it is coming here. So Thinkspeak. Okay, you can see here Thinkspeak login. You can log in. Then you can sign in. Log into Thinkspeak IoT. You can log in here. So log in Thinkspeak IoT. So log in Thinkspeak IoT. Here, if you are a new user, you can see at the top right corner, if you are a new user, it will ask you to register. Since I've already registered, I can directly sign in. I'm already there, I can sign in. So I'll just click on this. So when I click on this, it shows authenticating and it shows my channels. So these are the channels what I have already created. I worked on that. So I have already created channels. So you can see here my channels, right? So I have created 3 channels when I did the experiments or projects. One is LED glow, DHT, and first. Suppose you are starting with a new project and you want to record the values, you have to start a new channel. So go to my channels and just click on new channel. Getting? Are you able to understand till now?
Yes, ma'am.
Or should I explain once again? Shall I go ahead?
Yes, ma'am.
I'll just repeat. Go to Google, then click on Thinkspeak, or you just type Thinkspeak. Then you will get a series of display. Then go to Thinkspeak IoT. Since you're a new user, you can register for it. Then log in. I have already registered. I have logged in. Suppose you are doing a new experiment, you have to create a new channel. If you are doing a new project, you have to create a new channel to record the values of that. So go to new channel. In the new channel, I have the name here. You can give a channel name. Suppose you are doing a project on weather reporting. You can type as weather reporting. About description of that project, it is for your personal thing. Or you can make this public. That is, if you take some values from sensor, say temperature, humidity sensor, you're taking the values. If you make this channel public, anybody sitting in any part of the world can see what you're recording, can see your values. Anyone can see if you make it public. Okay. If you are making it private, it will be seen only by you. Okay. So that also I will show you. So give the name for the channel which you created, give the description for that, and give the fields. Fields is nothing but, suppose you want 1 graph, 2 graphs, 3 graphs. So for each graph, we give the field name. So field 1, field 2, field 3, field 4, like this. So up to 8 fields is permitted. And then at the end, you come here and you save the channel. Other things you need not fill. Not required as of now. Okay, then save. Click on save. Okay, so a new channel will be created like this, and a channel ID or channel number will be given. This is very important. This is very important. Channel number is very important. Through this, we are going to link our code to cloud. This is cloud. We are in cloud now. I hope you are understanding. We are in Thinkspeak Cloud. We have created a channel in cloud. And for that channel, we are sending the data, sensor data. So access is private. Okay. So then you can make it public also. Okay. By sharing it. Share channel view with everyone. You can make this public also. Okay. Or you can make it private. So then coming to the channel settings. So channel settings, name of the channel, description and all you can give. Then sharing, that's what you want to make it private or public. That option can be given here. Or suppose you want to share it for a particular user, you can use this email ID so that the readings will go to a particular user. Then we have API keys. API keys, write API key, read API key. So suppose you want to generate a new key. It's like password. You know, encryption and decryption. There is a secret key. There is a secret key. Yes or no?
Yes, ma'am.
Yes, ma'am.
So higher semesters. So like that, we have write API key and read API keys. Okay, I'll show you how they are used. So API keys are very important. If you generate a new write API key, a new key will be generated. Okay. So here you can see write a channel feed. You have get. That is, if you are writing something, you have this URL that has to be used. If you are reading something, you have this URL that has to be used. Okay. So as of now, since I'm showing the simple projects, we are using this field, the first one, Thinkspeak.com update. Why I'm using this update? Because continuously you will be receiving the sensor values and continuously your values in the store, that is in the database, changes. Okay. So I'll demonstrate a project using this Thinkspeak Cloud now. So any doubts in this part? If you create a channel, you will be getting a channel number, channel ID. Okay. Okay. 1 second. I'll demonstrate project. The project is like this. I am making lights on off using cloud. I'm making lights on off using cloud. I'll show you once. So for that, show you the connections. So here I've used Node MCU. You have to place the Node MCU on the breadboard. And on another breadboard, I have connected LEDs. 3 LEDs I have connected because I want to show you the use of fields. Field 1, field 2. In channel settings, you have this, right? Field 1, field 2, field 3. Since I'm using 3 LEDs, I'm using 3 fields. I hope you're clear. Now I want to power this Node MCU on. So I'll plug it to the laptop. You can directly plug it to the laptop, but you have a different cable for this to connect to Node MCU. You have a different cable. The pin is different. Okay. So to connect Arduino, the cable is different. To connect Node MCU, it is different. Okay. So I'm connecting it. I'm powering it. You can see the light blinking, blue color light, it blinked.
Ma'am, what cable are you using?
This is a cable that is mainly used for Node MCU. It is a set. Okay, power cable, that's it.
Oh, okay.
It's a power cable. I'm powering it on. That is, see, it is like this. The power input is this much.
Oh, okay.
So for that, you cannot use the Arduino, the cable which you use for Arduino. For Node MCU, you have to use a different cable. It comes as a set.
Okay, ma'am.
Yeah, so as soon as I connect, a blue light will turn on. Did you see? Yes. Okay. So now the connections are very simple. In Node MCU, here I am showing you in Node MCU, we have data inputs. That is, here you can see D0, D1, D2, D3, D4, D5. That is for data inputs. Okay. And ground is there, Vin is there. Okay. So all these are for supporting the data input. Okay. So we basically use data 1, data 2, data 3 here in this project. So what I have done, it is very simple. I have placed this node MCU on the breadboard, and the D1 is connected to the LED, green color LED. Can you see green color LED? Anode. D1 is connected to green LED anode. Okay. Then D2 of this node MCU is connected to yellow color LED anode. And D3 is connected to red color LED anode. Can you observe this much? This part only you see. I've taken inputs, that is D1, D2, D3, and I've just connected to 3 LEDs, anodes. Clear?
Yes,
And
ma'am.
every
Yes.
connection should have a ground connection. So what I have done, I have taken ground from node MCU, ground wire from node MCU, and I have connected to the ground
Red
cathode of red LED. Okay. So from here, I have connected to the cathode of yellow LED. And from here, I have connected to the cathode of green LED. That means all the cathodes are connected to ground. You know that the columns are connected in this breadboard like this. So make it a point to see that the D1, D2, D3 are connected to the LEDs anode, and ground connection is given to cathode. Is this much clear?
Yes, ma'am.
Simple. This node MCU has a capacity to connect it to network, but it won't work for 5 megahertz. So, sorry, not megahertz, gigahertz. It doesn't work for 5 gigahertz. I have to use 2.4 gigahertz because the capacity of the node MCU which I'm using is of 2.4 gigahertz. Behind this node MCU, they instruct you to use 2.4 gigahertz. You have to see this. Okay. So my home internet, it works at 5.8 gigahertz. So what should I do now? I'll use my phone hotspot. I'll use my phone hotspot. 1 second, I'll connect it. If you have 2.4 gigahertz internet at your place, it is fine. You can connect it to that, but I don't have. So what I'm doing, I am connecting it through phone. So I go to hotspot. If you are doing it with phone, you can do it like this. Go to mobile hotspot, just long press it and go for 2.4 gigahertz frequency. Okay, 2.4 gigahertz frequency. So then only I can work with this project. Okay. So I'm already set. So now I'll go to my internet connection and I'll go for the mobile network. I have to give my password for that. Now, so we understood about cloud. We understood about the frequency in which the node MCU works. So now I will go to the programming part. As usual, you need to open your Arduino IDE. Arduino IDE is Integrated Development Environment. So I'll go to that part. So I have already taken the code because it takes time to write the code. You have to LED control from Thinkspeak. Are you able to see the screen?
Yes, ma'am.
Yeah. So I'll show you how you can get the code and all. I'll show you. It's not that tough. You don't think that you need to code everything. It is available. I'm opening it. Yeah. So this is a code to send. I mean, this code, it is receiving the data from cloud. This code is receiving data from cloud. I will send the instructions from cloud and it will work. Okay. So here you can see the code. We have # include thinkspeak.h. So you should include this library. Include ESP8266 Wi-Fi.h. So suppose you want to include some library, go to Sketch and include library. See, many libraries are already included, like GSM, keyboard, mouse, robot control, robot IR remote, robot motor. So many libraries are included. Here, if Thinkspeak library you need to include, so go to include library, come down. Yeah, can you see Thinkspeak here? Thinkspeak? Yes or no?
Yes.
Yes. Only if this library is included, you can work on it. Otherwise, you cannot work with this project because you're connecting your code to cloud. Which cloud? Thinkspeak Cloud. So that library, the package should be installed. So it is, go to, if it is not installed, you can go to include library and then these are so many libraries that are included. So here add.zip library, go to Google and type Thinkspeak library and download it and add.zip library. You can do it easily. You might have downloaded so many games and all, you know how to do it. You have to just go to Google, Thinkspeak, then download and add it. That's it. Okay. If you're not understanding, I'll tell you later about this. Okay. So first we'll complete the project. It is a little lengthy project. So I hope you understood how to include this, include Thinkspeak. Then we need include ESP8266 Wi-Fi.h. Even this is a library, like this only you need to include. Since I've already experimented with this, I have already included it. It's a very easy job. That's it. Go to Google, download in some folder and keep, then include. That's it. It will automatically come here. Okay. Why ESP8266 Wi-Fi is required? This ESP8266 Wi-Fi is for this node MCU. This node MCU is also called technically ESP8266 Wi-Fi. Okay. So then you need to include this server. You know, you communicate through server only, right? So this server, see, I tell you, when you include this ESP8266 Wi-Fi.h, automatically these two also will be included. That is ESP8266 web server, ESP8266 MDNS. Automatically they will be included. So I hope up to here it is clear for you. And then we created a channel in Thinkspeak, and then we are assigning the channels LED1, LED2, LED3. Now please relate in your mind, please relate this to Thinkspeak. So LED1, that is the field name, LED2 is the second field name, LED3 is the third field name. Okay. So LED1, I'm assigning it as 1. LED2, I'm assigning it as 2. LED3, I'm assigning it as 3. And the serial begin, it is the baud rate with which this microcontroller works. It is common for all, whether it is Node MCU or Arduino board, 9600. And delay, it is 100 milliseconds. Okay. So in that delay, the LEDs work. Okay. I'll show you that. So pin mode, D1, I told you from Node MCU, I'm taking D1, D2, D3. So that is D1 is output. D2 is also output. D3 is also output. Okay. Then you need to connect. When you connect, if it is not connecting, when you try to connect, if it is not connecting, it will just print dot, 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 dot. When you try to connect, and if it connects, then it will show Wi-Fi connected, IP address, Wi-Fi dot local IP. All these details about your network will be displayed. If it is not connecting, it will simply display dot, 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 dot. That's what the programming is telling. Understood? Then void loop, we have put this part in the looping part. That is LED1, LED2, LED3. Thinkspeak dot read float field channel 1. So this is from Thinkspeak dot. That means when we use dot, we are accessing something from somewhere, right? So here Thinkspeak dot read float field. So I'm accessing it from Thinkspeak. So it's object, right? So Thinkspeak dot read float field channel 1 lead. So this part, especially this part of the program, is used to get the values from cloud. I'm trying to control this LEDs from cloud. Okay, so I have a device here, firmware Node MCU, which is helping me to connect to cloud. So then coming to this part, if LED1 is 1, 1 means high. If LED1 is high, digital write on. You know, you're all good in digital electronics. ADE, 1 is on, 0 is off, right? That's what is told here. So LED1 is 1, D1 is on, LED1 is 0, D1 is off. So LED2 is 1, D2 is 1, that is on. So we are initializing it to on status, status on. Then that part we have done here. So then we are going to print it in the serial monitor. Where is the serial monitor? Can anybody tell me where is the serial monitor? Serial monitor is at the top right corner. Here we can see the results, right? So, and the most important part is you can see SSID, Shalini mobile. Okay, I'm connecting it to mobile because I want 2.4 gigahertz frequency. If you have 2.4 gigahertz frequency at your place, you give your Wi-Fi username password. So I'm giving my mobile username password. Okay, and then here it is asking channel number. My channel number is 1625431. As soon as you create a channel in Thinkspeak, you will be assigned a channel number. So this is the channel number. And write key API, I told you, secret key, my write key API. That is, you are writing data from cloud to LED. So write key API you need to take, you copy paste from cloud. So which are all the things you need to copy paste from cloud? Can you tell me? What data you need to copy paste from cloud? What data? The channel ID and
Right API.
yeah. So these two things you have to, because from here only we are connecting it to cloud. And which network are we using? I'm using my mobile network. So I'm giving my username and password here. Got it? Yeah. So now what I'll do, I'll go to cloud. I'll go to cloud. I have already created a channel. So I will go to my channels. In my channels, LED glow. See, the new channel now what I created is given here. Can you see? It is locked. Means the channel doesn't have any data as of now. Can you see? Yeah,
Yes,
you
ma'am.
name the channel. You can name the channel. I have not named the channel. You can give your any name to channel. So I have already created a channel for LED glow. I'll open that. Okay. In that, I will go for channel settings. In channel settings, the name what I have given here is LED glow. Then field 1, field 2, field 3. Why I have taken 3 fields here? Why I have taken 3 fields?
Because we have 3
LEDs.
Three
There are
LED.
3 LEDs. Suppose you have only one sensor. Now I'm showing for LED. Next I'll show for sensor also. So since I've taken 3 LEDs, I've shown 3 fields here. Understood? Yeah. So then I have saved the channel. Suppose you want to make some changes, you can come down and click on clear channel. Okay. So I've taken 3 fields. I've named it as LED1, LED2, LED3. And now I'll go to API keys. This is what I have copy pasted there in the code. Right key Z, G, E, L, Z. This is the key what I have copy pasted in the program. Just now I showed you the program, right? In that I have copied the right key. And now I will come down. Here I have this write a channel feed. So what I'll do, I'll copy paste this. I'll copy the complete URL. Okay, copy it and go to the new tab here. Okay, and then paste it. Just go to new tab and paste. But since I have 3 fields, here I can see only 1 field. So what I'll do, I'll take this part. Okay, right click, copy, paste. Okay, and one more time I will paste because I have 3 fields. Understood? Or shall I repeat? You have to go to right channel. You have to go to write a channel feed. You copy the complete URL and come down to new tab and just paste it in the URL space. Got it or not? And I have 3 fields. So that is field 1, 0, field 2, and field 3. So I'll change it as field 1, field 2, field 3. And I will make, see, field 1 is for LED 1, field 2 is for LED 2, field 3 is for LED 3. I want to make second LED to glow. So I will make it as 1. That is middle LED to glow. I'll make it as 1. And suppose I want to make the last LED to glow. I will make this also 1. Okay. Then enter. Can you see a number here?
Yes, ma'am. 36.
What is the number?
36.
36 times I have made this program to run. It shows the number of times I have worked on this particular channel, on this experiment. Okay, so now once you get this, you come back to your code. Where is the code? I'll go to the coding part. Here is the code. See, we have pasted this. Yes, yeah, here is the code. So now I will verify the code. It takes time. See, can you see at the bottom? It is compiling.
Yes, ma'am.
It is dumping the code to Node MCU. It takes time. And meanwhile, you can observe which port is selected here. COM7. It is COM. We call it as COM7. That means this Node MCU is taking the data from COM7 of my laptop, port COM7. So it should be checked here. If it is not checked, make it check. Otherwise, it will not give the results. Yeah, can you see? Done compiling?
Yes, ma'am.
Yeah. After that, you need to upload to Node MCU the complete code. It also takes time, little time. Yeah. So now it shows that it is connecting. Can you see at the bottom, writing at 7% done, 15% done, 23, 30, 46. Can you observe?
Yes, ma'am.
So the code is writing on the board. Okay. Now finally you can see done uploading, right? So in the serial monitor, if I turn on, what can you see?
Day 1 is on, day 2 is on, day 3 is on.
Yeah, it is showing the results. So from where I'm taking the input? From cloud. Okay, see now 1 second, you can see here. All the 3 LEDs are on.
Yes, ma'am.
Okay. So this LED, I was able to make it turn on from cloud through that URL. So why I'm getting the results? Can you see the serial monitor? Yes or no?
Yes, ma'am.
Yeah. So it is showing like this. So it is very simple connection. So from cloud, I could operate it. And again, if I want to go this and see here, can you see here? Field 1 will change 1 second. One second, I'll go to this. I'll copy this and go to a new tab and paste. So I'll do the same thing again. Copy, paste, paste. So now I will make all zeros. So field 1, field field 3. Then I'll enter. So 39, which is showing. So then I'll come back here to the code. Then the serial monitor. Can you see?
Yes, ma'am.
Yeah. So see, I made, see, all LEDs are off. Can you see now?
Yes,
I 0 to all fields. So I'm controlling this through cloud. I'm sending instructions from cloud to switch off all these lights. So it is showing in the serial monitor also. 0, 0, 0. I didn't do anything here. I sent instructions from URL. It's wonderful, right? How you can work with cloud, right?
Yes, ma'am. Yes, ma'am.
So like this, you can try out with different projects. From cloud, you can switch off on lights and all. So coming to this Thinkspeak. One second. Yeah. So now we'll see what are the changes we can observe in Thinkspeak. I'll come here. I'll go to my channels. In my channels, I'll go to this LED glow channel. In LED glow channel, I can see graphs. This is recorded in the cloud. Whatever the result I can see here, LED. You think that these LED are at home and cloud, from cloud we are operating, right? So LED glow for field 1, when the LED was on, when it has become off, again on, off, like this, off. You can get in the form of graph also. So you can see 10th Jan, date you can see here. LED.
Yes, ma'am.
I experimented this on 10th Jan. It has recorded this. See, it is showing dates also. Tuesday, Jan 4th, Jan 5th. Right, LED 1 was 0. So you can keep track of the LEDs on, off, using graphs also. You can obtain in the form of graphs. Suppose you want to have the latest value. You can see here the last entry, less than a minute ago.
Yes, ma'am.
So it is recorded the latest readings. Suppose you want to get the latest readings, you can refresh it. Just than a minute ago. You can see it in the form of graphs. See, this itself is a project, right? Small project. You can use this concept in your big project, in your final year project. You can use this concept, isn't it? Can we experiment with temperature sensor values?
Yes, ma'am.
Okay, so I'll connect it with the temperature humidity sensor. So what we have here, can you see this? This is a temperature humidity sensor. It shows the temperature as well as humidity. Okay. It is connected to Node MCU. We are using VIN, that is input and ground. See, it has 3 pins. This Node MCU, it has 3 pins, one for VCC, one for ground, and another is for data. One for VCC, another for ground, and another is for data. You can use this to find out the temperature readings. I have created a channel for this also. DHT sensor. So I have got the graph here. Actually, yesterday night I was working with this. Net was not proper, internet. So I was getting temperature as 0. So it shows the importance of internet. But on that day it was proper. So it was showing 25.9 degrees. When it was showing 25.9 degrees, on Jan 10th, temperature and humidity, humidity, the amount of moisture and what you can say, the feel of warmth in the air. So that is humidity, right? So the humidity value is 59 on, you can see here, it was 59 on Jan 10th. So it was 95 on Jan 10th at this time. Time also it is showing, right? See, all these recordings are important, right? If you want to forecast the weather, that is how they do it. I told you in the North Pole, South Pole and all, people cannot go and stay there, right? So what they do to find out the weather readings and all, they just put these type of sensors, maybe higher versions or more sophisticated sensors, and they get the readings. So we'll work on this. We will see how it works. So I have I'll connect it. I'm just giving power supply to the CU. And it's very simple connection. VCC should be connected to VIN, ground should be connected to ground, and the data is connected to D7. And there are GPIO pins in Node MCU. The GPIO numbers are different from the numbers which are given here. So that is D0, D1, D2, D3, D4, D5, D6, D7. Okay. GPIO 13 is D7. GPIO, that is general purpose input output. So I'll tell you about this concept in Raspberry Pi also. The GPIO numbers are different and pin numbers are different. Okay. So in the program, we use GPIO numbers, but you should know for which GPIO number, which pin are we using. Okay. I'll go to that. So in this, I have DHT. For DHT, I have this. I'm opening the code. So IDE is Integrated Development Environment. You have already installed IDE. Then only you can work. One second, I'm opening it. DHT sensor. Yeah, this is the code. You find a similarity between the previous code and the current code, which I have put here. Can you find the similarity? What are the similarities? Can you tell me? What similarities you can see? What is this? Username, password, right? And then we have included DHT.h. DHT sensor. Since we are using the temperature sensor, we have to include DHT.h library. Without including DHT.h library, you cannot work with temperature sensor. So if you have connected properly, the light will glow in the temperature sensor. If you have not connected it, it won't glow. Okay. I told you how to include the libraries. You have to go to Sketch and then include library. You just check if the library is already installed. If it is not installed, you have to install it. How to install? I told you, you have to go to Google and you have to just type DHT library. it will download and add zip library. Just add it, it will be coming here. It will be displayed along with these libraries in alphabetical order. So DHT library is already there. You can see over here. Here, can you see DHT sensor library?
Yes, ma'am.
These libraries you cannot work. So DHT, once I include this library, the next one, hash include DHT u.h, it will automatically come. Okay. So then this is API key. I have copied this from Thinkspeak. Okay. And this is my mobile phone username password because I'm using 2.4 gigahertz frequency because this node MCU works at that frequency. And then I have DHT pin DHT11. So this is the keyword DHT. So for that, I'm using the two values. So the baud rate is given as 9600 and delay is 10. That means for every 10 milliseconds, the temperature readings will be sent. Okay. So then connecting to, this is what I told in the previous program also. If it is properly connected, it will show it is connected. If it is not connected, it will not show, right? So the same part, it is same as the previous program to show the connection. If the connection doesn't establish, then it shows as fail to read from DHT sensor. Doesn't happen. Then if it actually reads, then it keeps reading the temperature. If it works out, it keeps reading. So we will see how it works. So first I need to verify the code. And don't be scared that these components might harm you. No, they are not that much powerful components to harm you, but take care that the components are not spoiled by making wrong connections. And initially, if you are experimenting with all these sensors and all, you will spoil some stuff, but don't get disappointed or thinking that the components will be spoiled, so you should not do and all. Don't think that way. Okay, one temperature sensor gone, let it go. It is 235 rupees. If LDR, if you take, it is just 20 rupees or 30 rupees. You are learning, you are in the learning process. Let it go. You are going to learn. But before making connections, don't be in hurry to make connections and to see the output. Before switching on any component, any sensor, see the connections once, because you might spoil the sensors or the board itself. This board is costly in the sense it is around 850 rupees, right? So be careful, that's it. Many of the students, they don't go for this IoT experiments thinking that they might spoil the components. And they are scared that the boards might go, or their parents might scold. How many times you are asking, you have spoiled that, this and all. But it's okay, right? You can, in the beginning, I told you, it is just 20 rupees LDR. This is 235. This is I can say the more costliest sensor. LEDs, you will, for 10 rupees, you will get 3 or 4 LEDs. So you can use it. Breadboard, you will get it for 60 rupees. You can use it. Okay, so you can see done compiling here. Yeah. So then I have to load it on the MCU, node MCU. It takes time. Now you can see here 7%, 15%, 23%. So the code is being loaded onto the node MCU. If you go abroad for studies, higher studies, they mainly consider the projects. They don't consider your assignment marks or internal marks. They consider your projects. They ask you to do n number of projects. They are the assignments. Actually, assignments are your projects. You have to do projects. So if you go abroad after completing your BE, if they ask you to do some projects, it will be very tough for you. So start doing some hobby projects at home so that it will be easy for you when you go abroad. So you will not think that you have landed up somewhere where you don't know anything. So start with this. Okay, there is a reset button in Node MCU, like we have a reset button in Arduino board. So just press it over like this, so that any previous junk values are there, they'll be removed. You are going to reset so fresh. Okay. So then, can you see here serial monitor, Wi-Fi connected? Can you see the temperature? What's the temperature?
29.70 degrees.
29 degrees. Humidity is 64%, right? So again, it is giving 20. The delay, you can see the delay. After some time it gives. The delay you can set in the code. So suppose I want to make the humidity more. I will blow over it. Can you see the increase in humidity? Or if you bring some matchstick near it. See 90%, 95% humidity. Can you see?
Yes, ma'am.
Also has increased because I just blowed on it. See the temperature sensor, temperature and humidity sensor. So it is reading the values. And these values can be sent to cloud. And you can record these values on that particular day, particular time. What was the temperature of that particular place? Right. Slowly it is reducing now. Humidity, can you observe? 80%. Yeah. So this actually we can go and see in Thinkspeak Cloud. See, here we don't copy. I'll show you. Shall I go to Thinkspeak Cloud now? Yeah. So I will go to my channels. Then I'll go to DHT. This shows the recording 12 hours ago. That is, yesterday I did. So it takes some time because it depends on the speed of internet. You can observe here the temperature. Monday, I just showed you, right? It has increased. Sometimes it takes time. So you have to keep refreshing. If the network is little down, you will not get fast. It may show after 5 minutes also, but it will show. It has to reset. So, and one more thing is, go to channels, my channels. Okay, come to API keys. In API keys, you have this read channel feed. So just go here and then copy, go to new tab and then paste. You can see this is displayed in the cloud. So the channel, it's a code. JSON, you know about JSON coding?
Yeah.
This is the JSON coding.
You joined already. Where are you?
So ID, this one DHT, latitude, longitude, temperature value, field 2, all these things will be displayed over here. So if I come here, maybe my internet is a little slow, phone's internet. Just okay, but it will record here in the graph. Okay, you can use widgets options that are present here, add widget. So it can show in the form of meter, or you can show in the form of numeric display, or you can have a lamp indicator and so on using widget display. Again, I'm compiling it. I think my net is a little slow, so it is not reflecting in this one, but previous value, what I have recorded, I've shown there. It's compiling. So you can use this also as a part of your project, final year project, sensing something and sending it to cloud and getting a graph. So you can use it. And you can still more attach this one, machine learning concepts, artificial intelligence concepts, you can attach to it. So I think yeah, for robotics and all, these are all basics. It's compiling. It takes time because it's such a small board and everything is happening on this board. So can anyone tell me what projects can be developed using the concepts which I told you from morning? Can you list out the projects?
Ma'am, if you combine all of them, suppose the LED project and this DHT project, you can get, soil moisture levels, and depending on the change of the moisture levels of the soil, the LED might indicate, by glowing up, something simple like that. Or you can even, instead of DHT, if you can get a pH sensor of the soil, then whenever you plant, let's say you have a tool to just stick it into the soil, and then based on the pH level, the LED will change its color.
Yes, very good, Rahul. I'm happy that you are attending the workshop. Any other ideas? Can we have a traffic light signals?
Yes, ma'am, based on camera feed data.
You have observed traffic lights, right? Signal lights. Is there anyone standing there and controlling it?
No, ma'am.
Few minutes, it will be green. For next few minutes, it will be yellow. Next few minutes, red. Who is controlling it? No one controls it. How it works? It's a very simple technique of what I've shown, morning LED glow. Instead of using one LED, connect 3 LEDs and give the delay between them. It becomes the traffic signal. You can make traffic signal out of it.
Yes,
right?
ma'am.
Then it's the simplest thing what you can make, the traffic signal. And then
suppose you have any, let's say a big server room, you can, read its temperature. Suppose the AC unit fails inside the server room. The temperature will, the sensor will alert you by, let's say it's attached to some buzzer unit, and then you will get a message saying that, it will make noise indicating that temperatures are rising below normal. Sorry, above normal.
Yeah.
then you can, try and fix the AC unit or shut down the entire server room.
Yeah, that's really a good idea. And using this cloud and the sensors concept, can you make some projects? I just told you how to use clouds.
You can set up proxies, like proxy servers, or you can use these little Arduinos, or let's say if you have a Raspberry Pi, you can set up an ad blocker. When you browse the internet, you can set up an ad blocker, or you can even program your own VPN.
Anybody else? I have just taken Thinkspeak as an example. Suppose you are using some other cloud like AWS cloud, and it also depends on for what purpose you are using. Okay. Suppose you want to store data, you want to use it as a database, you can use some other cloud, AWS cloud, Amazon cloud, and all. So this is how it works basically. This is how it works, and I think you can come out with n number of projects. I've just shown one sensor, temperature sensor. My students will be presenting many more sensors in the afternoon session with a lot of enthusiasm. And they're demonstrating the projects also. They're going to demonstrate how they started the project, what was their experience and all. And the students who got selected for KSCST, that is Indian Institute of Science recognized projects. They're funded for the projects. So those students are also coming, alumni. Students are also there in the afternoon session. So I request all of you to be present for the afternoon session also. I know interested students only are here who wants to learn something on this and all. So we'll have a interactive session in the afternoon. You can talk to them. So till now I told you about cloud, right? And how to control your gadgets with cloud, right? I just showed you about LED. I just showed you about a temperature sensor. You can use other sensors also. I just given a sample example. That's it. Then you can use other sensors like soil sensor, moisture sensor, soil moisture sensor, and ultrasonic sensor, PIR sensor. You can use all of them, okay, and create your own projects. Okay, and you can use all of them in the sense you can use all the sensors in a single project. It is also possible. So now I want to move on to one more board, that is Raspberry Pi board. I think all of you are aware of Raspberry Pi.
Yes, ma'am.
Yeah. Raspberry Pi, I'll show you. This is the Raspberry Pi board. This is the Raspberry Pi board. Okay. I think. Are you able to see?
Yes, ma'am.
So Raspberry Pi, how is it different from Arduino? It's not that we can replace Arduino. No, we cannot replace Arduino. Arduino has its own importance. Node MCU has its own importance. And Raspberry Pi has its own importance. So how is it different from Arduino? In Raspberry Pi, we have a controller as well as OS. We have microcontroller and operating system. Like how we work with our Windows. Windows is an operating system, right? And Linux OS. Linux OS is an operating system. So like that, Raspberry Pi has OS, that is Raspbian OS. It is similar to Linux. It works with commands. Okay, and you can say that it is a pocket-sized computer. Pocket-sized computer. You can carry this computer wherever you want. This is a computer. If you install OS into it, it becomes a computer. How? I'll tell you. We can input SD card you can input SD card to it. Okay. Here, you can see the slot. You can see the slot here.
Yes, ma'am.
In this slot, you can insert SD card. You use your SD cards in phones and all, right? That SD card, you can use 16, 2 GB, 64 GB SD cards. You can use different types of SD cards, 16 GB, 32 GB, 64 GB SD cards. Okay, it depends on your usage. Suppose you're doing a project, you need to use 64 GB SD card. Suppose simply for checking the temperature sensor values or to make LED on, off, or to control your home, that is, I can say home automation system, 32 GB is enough. A simple light on, off, or you're working with Alexa, that is enough. So here you can insert the SD card. In this SD card, we are dumping the OS. Raspbian OS is put into the SD card and it is inserted here. So now your Raspberry Pi has a OS now, right? And you can see the USB ports here. Can you see the USB ports?
Yes, ma'am.
Yes, ma'am.
In the USB ports, you can connect USB keyboards and mouse. So wherever you go, you can connect it. You can connect it to USB keyboard and mouse. And here you can see internet cable. You can
Ethernet port.
Yeah, you have internet port. So what else you need?
Type C HDMI
you can
port.
attach a camera to it. You can attach a camera to it, and antenna also. You can do so many things with Raspberry Pi. Actually, I want to conduct a separate workshop for Raspberry Pi, but you have to get used to with small stuffs like how you can work with Arduino and all that. If you're comfortable with that, you can move on to Raspberry Pi. Okay. My project students have used Raspberry Pi in their projects and they felt it easy. Initially, you might feel it tough to install SD card, to connect and all. And you have HDMI port here to connect it to the monitor. Can you see? You have HDMI port here. You can directly connect it to your monitor. So what else is required? So it's a pocket computer, right? I can carry it anywhere and I can use it as a computer.
You also have I/O pins on the side.
Yeah, we have I/O pins on the side, like how we have for Arduino board. We have input-output pins. We have 40 pins. We have 40 pins, GPIO pins. They're called general purpose input-output pins. We have 40 pins. We can start counting from this side. One, it starts from here and it ends here, 40. We can use all the pins for connecting. So it is having microcontroller also. Microcontroller like what we had on Arduino board, we have that also in this. And this Raspberry Pi, what I'm showing now is Raspberry Pi 3. Pi 4 is also there, and 0, that's very small. Raspberry Pi 0 is also there. Okay, many new upgraded versions have come. Okay. And we have this in our lab. You can come and work with this. So I'm just introducing Raspberry Pi here, and you can work with sensors. You can work with home automation. You can work with internet also. And it has, see here, there's a port to connect to internet cable, right? We can connect to internet also. I'm using Raspberry Pi 3 here. Pi 4, you can directly connect to internet. It has a Wi-Fi enability also. You can directly connect it to your Wi-Fi internet network, Pi 4. 1 second, I'll stop this screen share. So next time, when time permits, I will do a separate workshop on Raspberry Pi. It is ocean. You have so many things are there to tell in Raspberry Pi. 1 second, I'll share the screen. Can you see here, Raspberry Pi? So it comes from the fruit raspberry. That name comes from that fruit. So okay. So
Make sure you're muting.
how to install the OS? I'll just give you instructions if you are interested to work with Raspberry Pi. You can do like this. Yeah, you have to go to raspberrypi.org. One more thing I want to tell. Previously, we used to install OS in Raspberry Pi using SD card. It was really a tedious process. It was not that easy. Now they have made it very easy. Actually, I came to know last month, 2 months before. Okay, maybe in July end, they have changed the OS completely. It is a different OS now. Okay, and the installation process is different OS in the sense completely upgraded version of OS. You can do still more, lot of stuffs. Okay, so I think somebody's phone is ringing. So Raspberry Pi, it has changed since last 2 months. The complete process has changed. I've seen that actually how I came to know after a long break, that is a COVID break, the 2 years, I didn't work with Pi. I didn't work with the Pi in the sense I had SD card, I had installed OS in that, and I was working on that, but I didn't venture into installing a new OS. So then I am doing project with my CS students, and I told them to install it. And it's my experience, I want to tell. And they came and told me, ma'am, it is not installing. Then I told, it is very easy. Why are you feeling it so tough? But steps are lengthy. Then again, they called me, ma'am, it is not installing. From lab, they were calling me. Then I told, why are you feeling it so tough? It's not that tough. Only steps are lengthy. Then I went there to lab. I went and I saw. Then I came to know that the installation procedure has changed, and the OS they have upgraded. Okay, so it is very easy now. Previously, it was little tough, but still, I have to appreciate my students. They have done projects with Raspberry Pi from 2016. They are doing projects with Raspberry Pi. They at that time the installation procedure was tough. Okay, and many times because of wrong code, what they do, the SD cards have crashed. They've crashed. But still, I have to appreciate the patience of my students. They didn't go down. Again, they took new SD card. They formatted the SD card. You had to use a separate command to format SD card. You have to use a separate command to install OS. You have to use separate command to update. So many commands. Now it has become very easy. Anybody can install OS into SD card. So it has come just now. That is from July end. They have done like this. It has been upgraded. It's very nice now. Anybody can start doing projects with Raspberry Pi. So you have to just go to raspberrypi.org. You can see the website here. And here you have Raspberry Pi Imager. Okay, you have to go to Raspberry Pi Imager and just click on that. And you have to insert SD card into card reader. I hope all of you know the card reader.
Yes, ma'am.
Put that SD card into the card reader and put it into the laptop, insert, connect it to the laptop. So then just go to Pi Imager and click it. Then it will be installing it in your SD card. The OS will be installed within few minutes. Okay, what I wanted to tell is the procedure is very simple now, not complicated as how it was before. Okay. Anybody can do it. So I'm planning to do a separate workshop on Raspberry Pi 2. But when time permits, I'll surely do it. But those who are interested, can start now itself with Raspberry Pi. It's very easy to do and work with, and it's fun to work with. You have so many options in that, and you can do a pretty number of good projects. And my students, those who got prizes and got funds, all projects are Raspberry Pi they used in all projects. They used Raspberry Pi in all projects. So
hello, ma'am.
try to use Raspberry Pi. If you want to explore more on that, you come to me in college. I'll tell you how to work on that. You can see my current students are working with Pi. Your seniors have already worked and your alumni have already worked. It's not that tough. The only thing is you should have interest. That's it. Okay, I've just introduced you to Raspberry Pi. You can work on that also. You can do the same projects, what we have done using Arduino boards with Raspberry Pi too. You can do it. And
ma'am, just a minute. Yes, we'll be having lunch break from 1:30 to 2. You could go have your break and then rejoin the meeting, or you could just keep the meeting on and have your break.
Okay. And one more thing I want to tell you. One more thing I want to tell you. Here, we have go to Arduino.cc and just click on this. See here in Arduino.cc. Can you see the screen? Arduino.cc?
No, ma'am.
No, one second, I'll share the screen. And just go to the URL and type Arduino.cc. So you're into this Arduino world. You can see so many things here. Buy an Arduino, you can buy an Arduino, you learn Arduino, you can donate it, Arduino in the cloud, and you have so many things. Show off your Arduino projects. If you have done Arduino projects, you can show here. It is an Arduino community. It is open source. And so many other things are here. You can see here. You can buy components, sensors, and cloud games. So many things are there. Here, see Node MCU, they're projecting the things. And suppose projects, suppose you want to see the projects, you go to Arduino.cc and say I want to see temperature sensor. So I'll be getting like this. So go to Arduino.cc. It is the authentic code you're going to get here. Just on this. You can get a project. See, connections, components used, and then about the project and video of that project, everything you'll get here. You want code, you can get the code from here. You can copy the code and you can go there in Arduino Ide where you have installed in your system and you can run there. You can get the code for some of the projects. So it's not that tough. Code is available, components are available. Only thing is you should have passion and interest. See. If you want to add a project, you can add your project. And you can search for different projects, like you can search for fire sensor like this, and you can search. See, so many projects on fire sensors are given here. These are uploaded by students like you only. Because it's open source, you can do the projects and upload. See, so 37,370 views, sensor data streaming with Arduino, sensor station, sensor control. So many projects related to sensors are displayed. These are done by students like you only. Sensor board, displaying sensor values, like this. So like this, you can do projects. If you want to do projects, you can come to this Arduino.cc. You will get n number of ideas. You can combine the ideas and you can come out with a project of your own. And you can attach Arduino board to Raspberry Pi also. You can attach Node MCU to Raspberry Pi. Okay. In satellites, they use Raspberry Pi to send to the outer world. And the weight should be very less. So Raspberry Pi weight is very less. Its weight is very less, and we can attach a camera to it. So we can take pictures, the outer world pictures from satellite are taken with the help of Raspberry Pi. You can attach a camera. It works well. You can take pictures. Very good, high quality, high resolution camera you can attach to it. They're actually using in these fields. Raspberry Pi is used in satellites to send to the outer world and get the snaps. So more into Raspberry Pi, if time permits, I'm very much willing to do on this also next time. So we should have lunch break now. I think many of you are hungry. So at what time are we joining back, Harshita?
2 p.m.
2 o'clock?
Yes, ma'am.
Okay. So afternoon sessions will be very interactive session and it will be very nice. And students like you will be presenting the projects. You can talk to them.
Once again. Salim ma'am, can you remove that Kanchana? Please remove her.
Okay. One second. Kanchana. What's the name?
Remove her.
Kanchana.
The name is Kanchana only. Remove her.
Yes, ma'am. Kanchana.
Yes, ma'am.
So afternoon session will be more interactive because my students will be talking to you. They'll exhibit their project. You can talk to them, be interactive. You ask them how they started, what was their experience and all. Okay, we'll meet by 2 p.m.
Yes, ma'am. Ma'am, just to help, can you make Sahana or Sankarshana the co-host, because I left the meet and joined again.
Okay. Who I have to make?
Sahana or Sankarshana. Their names are there. Yes, ma'am.
Okay. Sahana J980.
Yes, ma'am. Sahana J.
Sahana J, make co-host. Then?
Sankarshana.
SAN?
KR.
Yeah. Sankarshana Huli.
Yes, ma'am. Correct.
Okay. I'll make you also.
Yes, ma'am. Done, ma'am. Thank you.
We'll have lunch and we'll join back by 2 p.m. Thank you.
Yes, guys, you can go for your lunch now and come by 2 p.m. We would be starting with the demonstration of projects.
Yeah, you can see the projects with Raspberry Pi also in the afternoon. You can ask queries also. Okay.
Meanwhile, if anyone has any doubts as such, you could ping in the chat box, or you can unmute yourself and ask us. Yes, guys, please maintain the decorum of the program and please change your usernames with valid names. If you have your USNs, name them along with your USNs, or if you do not have your USNs, please mention your full names. Only then we would be admitting you to the meet. Yes, you have any doubt, Shabari VE?
Yes, I'm a first year student.
Okay.
Actually, I wanna get to know nowadays these chatbots are getting famous. Like, what type of technology are they using in the chatbots? I wanna know.
Okay, so you want to know about chatbots specifically?
Yes, are they using this Raspberry Pi technologies in that?
Okay, got it, got it. We'll just wait for ma'am to arrive. Meanwhile, if anyone is okay with sharing your views on it, you could definitely do it.
No, they actually they do not use anything, related to Arduino or Raspberry Pi. They set up, AWS servers and they run daemon processes. Daemon processes is, in the sense, background processes that keeps running. So the AWS server keeps pinging, let's say, a WhatsApp chat to see activity, and then you keep sending GET requests, using the bot from the AWS server, and then on activity or on certain command, so say you type something peculiar into the chat box, it will start spamming any messages that you have pre-coded into the chatbot, or
Okay.
any commands. If you use it, will say you have designated commands using a JSON file inside the bot code directory. So it will, based on the command, it will give you the appropriate response. But it
Okay.
can even be automated, saying that at certain times it will send you something. Let's say at every day 9 a.m. you want to send a good morning message to certain contacts in your WhatsApp.
Yes,
It
yes.
will, it will always be running, since it's a daemon process, it's a background process. So when the server times hits 9 a.m., this is important. You have to remember the server time should hit 9 a.m. So when it is 9 a.m. at the location where the server is present, it will start sending good morning messages to all the contacts, or whatever activity that you have configured to make it do.
Okay.
Hey Sabri, so you want to know like the Autobot which they use to, when you talk and you immediately get a reply, or like the reminder ones?
Yes, yes, the same.
The immediate reply ones, correct?
Yes.
See, so there are a few Autobots, all right, which are automatically programmed to give a specific output. Suppose if you go, like just for an example, if you have a problem with Geo network, you go to their WhatsApp number and you text them. The Autobot is already having a feed that it should give an output as a few of the list, and after that you try. There'll be like a numbers list, like 1 2 3 4, and it'll have like a specific information, like if you have problem with network, press 1, press 2. So everything is already auto fed. There's nothing
But
that is there is
but isn't
nothing
that
that is,
exactly what I said?
yeah, that's 100%, but he's in first year, and what you're trying to explain is something going over his head.
No, I mean, he asked, is it, hosted on a Raspberry Pi, or is it, he asked specifically, do you use Raspberry Pis in hosting such bots?
100%, 100%
So
no.
that was the reason I, had to explain the daemon processes and AWS stuff.
He will not know what is the daemon process. You can ask him if he knows so.
No, I, also explained what a daemon process was. It's a background
Yeah,
process.
that's why I try to explain it in a simpler manner so that he gets it.
All right.
I hope you got it, Sabrine.
Yes, yes. Thank you.
You're welcome.
Yes. Meanwhile, if anyone has any doubts related to how to join IEEE for AMC students or about the topic for today, you can just ping in the chat box or unmute yourself and speak. Also, guys, do not worry about the feedback forms. It will be circulated to you right after all the demonstrations are done. We will not be circulating the feedback form in any of the WhatsApp groups. It will only be put up in the Zoom session. So if you want the certificate and if you're really interested in getting a certificate of appreciation as such, you could demonstrate your projects in IoT and get the same. Okay, so anyone in this meet specifically want to demonstrate the projects, you can just raise your hands or put a message in the chat box. Yeah, for those who don't know when the afternoon session would be starting, it would be starting at 2 p.m. And the flow would be like the seniors would demonstrate their projects, which was approved by KSCST. And then we would have a few participants demonstrating their projects. After that, you can go on and ask your queries and questions to Shalini ma'am, and we'd be closing the event. Yeah, I think there are a few international students. You guys can join back in 20 more minutes. If you guys do not have the time track, join back in 20 minutes and then we'll be starting. Yes, guys, don't worry. I'm getting a few texts regarding the resources. We would be sending all the links and resources shared by ma'am in today's event. Do not worry. Good afternoon, everyone. We will be starting the session in a while.
Harshita, can we start?
Yes, ma'am, we can start.
My project students, they want to show the installation of Raspberry Pi OS. They'll show the installation in few minutes.
Okay, ma'am, sure.
Okay. Yeah, Sumant?
Yes, ma'am.
Yeah, Sumant and Shreyas, are you there?
Yes, ma'am. We are there.
I request
Yes, ma'am.
Sumant and Shreyas to show how you can install Raspberry Pi OS. Yeah, can share the screen.
Yes, ma'am.
Yeah.
So, good afternoon, one and all. My name is Shreyas, and I am currently a final year student, and I am from CSE department. So, you all may be wondering what is Raspberry Pi. Today, I am going to tell you about Raspberry Pi. So, Raspberry Pi is a low-cost credit card size computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and to learn how to program. 1 minute.
Yeah, you can share the screen.
So it is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python. It's capable of doing everything you'd expect a desktop computer to do, from browsing the internet and playing high definition video to making spreadsheets, word processing, and playing games. What's more, the Raspberry Pi has the ability to interact with outside world and has been used in a wide array of digital maker projects, from music machines and parent detectors to weather stations and tweeting birdhouses with infrared cameras. Sumant, can you share the pinout diagram of Raspberry Pi? Sumant?
I shared.
It's not visible.
Not visible. Wait, I'll just check. I've given the permission. Yeah, permission is given. Share it once again.
Okay, ma'am. No, it's visible. Shreyas?
It's not visible to me, ma'am. Is it visible to you?
No, I'll stop my share. Wait. You share? Yeah.
Yeah, now it's visible.
Yeah.
So basically, this is the pinout diagram of Raspberry Pi. So this one is 2x2 USB-A ports, which you can connect to keyboard and mouse. So below that it is Ethernet output port, and to left to it is 3.5 mm audio jack, and that is CSI camera connector, and this one is HDMI output port, and the next one to it is 5-volt micro USB power switching regulator for less power consumption, and that one is DSI display camera, and this one, the large one, is micro USB card slot, and the center of it is the main thing that is called processor, and next it is a Broadcom BCM 2835 processor, and next to it is run header user to reset the Pi, and there are like 4 squarely placed mounting holes, and those are the 40 GPIO headers. So the application, here are some applications of Raspberry Pi, which are desktop PC, wireless print server, media usage, game servers, retro gaming machines, robot controller, stop motion camera, time lapse camera. That's all. Now Sumant will tell you how to install Raspberry Pi.
Good afternoon, one and all. My name is NP Suman. I'm currently pursuing my final year BE in AIMS Engineering College, Department of Computer Science and Engineering. Today, I'm going to tell how to install Raspberry Pi OS in your PC. First, you should go Raspberry Pi OS install on Windows. After we are seeing Raspberry Pi OS. We should click on Raspberry Pi OS. You will get the screen like this: Raspberry Pi OS Imager installation. Raspberry Pi Imager we are installing. We here download for Windows, download for Mac OS, and download for Ubuntu for x86. We are downloading for Windows, so we should click on download for Windows. It takes around 50 seconds, 10 to 15 seconds. Oh no, it's downloaded. After downloading, we should install and finish it. We are seeing this. We should choose OS, operating system. The requirement for downloading Raspberry Pi OS is SD card around 16 GB or 32 GB or 64 GB. We are for our project, for final year project, we are using 64 GB. For small projects, you require it around 32-bit. It's enough for small projects like LED, temperature, and all. We are doing face mask recognition using Raspberry Pi. So we are using 64 GB SD card. You should insert into your laptop. After downloading it, you are seeing Raspberry Pi OS 32-bit. You should click on that, and you should choose storage. Means SD card. You should insert your SD card. SD card.
The SD card should be inserted in card reader.
Yes, ma'am. Card reader. Then you should write this OS into your SD card. Then you should remove that SD card and insert into your Raspberry Pi. Ma'am, that's it. OS installation. Ma'am.
Yeah. Thank you, Sumant and Shreyas, for demonstrating the installation of Raspbian OS. Now I request Supraja to demonstrate her project, hobby project.
Yes, ma'am. Good afternoon, one and all. Myself Supraja from CSE 7 Sim. Hope all are doing great. And I'm glad to be a part of this workshop under the guidance of Professor Shalini ma'am. Today, I'm going to present you all smart dustbin using Arduino Uno, which was one of our hobby project. Just a minute. Yeah. Smart dustbin using Arduino Uno. The content we are going through today is introduction, working procedure, components used for this dustbin, and circuit diagram, required software and reference. Yeah, this smart dustbin sends the person or an object using sensor, which sends a message to a servo motor using Arduino Uno. When the person comes closer to the dustbin caps will automatically open. After a certain time, it will automatically close. The working procedure of this dustbin is, this can also be told as an automatic dustbin. It works like when a person comes in front of the dustbin, it will automatically open with a servo motor, with the help of servo motor. So there is some sensor like it detects an object. Using ultrasonic sensor, it will detect an object. Like it works smart. It works same as in smart things, and it detects the garbage to make a home clean and attract. Kids will have fun with this dustbin. They can make use of to play with this, and they can even clean the home. And next, the components required for this dustbin is Arduino Uno. SDR19 micro servo motor and the spark plug ultrasonic sensor. This is Arduino Uno, which is low cost, flexible, and easy programmable open source microcontroller board that can be injected into a variety of electronic projects. This can be interfaced with Arduino boards, Arduino shields, Raspberry Pi, and also can be controlled with LED sensors and motors as an output. A servo motor is a small device that has an output shaft. The output shaft is positioned to a specified angle. We can change whichever direction we want. Like it will rotate like 90 degree, 180, even 360 degree. It completely rotates the servo motor. As long as the code signal exists in the input line, the servo motor will mainly angular the position of the shaft. Next, ultrasonic sensor. This ultrasonic sensor can measure the distance to a wide range of object, and it doesn't rectify any color or like a shape or a surface texture. It will measure any distance, and from the distance of 2 centimeter to 400 centimeter or 1 to 13 feet, it can measure. And this is a circuit diagram of our project. The required components are ultrasonic sensor, Arduino board, which plays an important role for every project, and servo motor and some jamping wires to connect the circuit. So I'll give some demo of my project. Just a minute. Yeah, this is a small demo of our project. Yes, thank you.
Thank you, Supraja, for demonstrating the project.
Thank you, ma'am.
They did this project within a day or two. They used ultrasonic sensor. As I told you in the morning session, ultrasonic sensor makes use of ultrasonic waves. So if anybody goes near the dustbin, it will automatically open. During this pandemic situations, we don't feel like going very near to dustbin and opening it. We can follow the protocols. So we can go near it and it will automatically open and we can put it into the dustbin. So thank you, Supraja. So may I now request Soumya to demonstrate her hobby project. Soumya, are you there? Shwetanjali?
Ma'am, she's coming, ma'am.
Yeah.
Try, but मैंने आपके लिए लिखा है, ठीक है? तो yeah.
You can do such small projects. You can start with small projects. They did these projects within a day or two for first year induction program. For that only they did these projects to show them how the components like Arduino and Pi can be used to do the projects. Yeah, is she there? Soumya?
Yes, ma'am, she's there.
Yeah.
She's coming.
You can share the screen, Soumya. You're not audible. Soumya, you're not audible.
Ma'am, I think it was muted.
It's muted. Soumya? There?
Yes, ma'am, she's present, but host stop.
Who is there? Co-host? Yeah, Soumya, now you can talk. Yeah. It's not muted, you can talk.
Ma'am, can you hear me?
Yeah, now I can hear you. Come from the first line.
Okay, ma'am. Okay, good afternoon to everyone present here. My name is Soumya J. I'm a final year student at AMCEC of Computer Science and Engineering branch. Firstly, it feels really great to be part of this workshop. When we were in third semester, ma'am had conducted a workshop on IoT, from where we have learned how to use Arduino, how to work with breadboards, and do small projects on them. So we are currently doing our final year project under Shalini ma'am's guidance, that is advanced and cost effective water management system to help farmers for better irrigation. Meanwhile, we have also worked on several hobby projects. So one among them is a smart blind stick using Arduino. So today I would like to demonstrate it. So the components which we have used to do this project is an ultrasonic sensor, which will sense the obstacles coming on the way, and a stick, an Arduino Uno board, a buzzer, 9 volts battery, LED light, and jumper wires to connect all them together. So this is the respective circuit diagram we followed, and this is our project. This is the image of our project. So we can't make out the connections properly here, so I have put this circuit diagram. And yeah, as the name suggests, it is a device for the visually impaired people. So it is to guide the user to respective destination and avoiding to collide with obstacles. So to reduce the accidents that they face. And how it works is the ultrasonic sensor which we have attached will detect the obstacles at a certain distance. So when the person is walking, if there is an obstacle, the sensor detects it, and the LED glows at the time, and the buzzer beeps, so that he will take the diversion in his path. So due to this pandemic, we could not take that experiment home. So it is with Shalini ma'am itself. So I will be showing you a demo video of it, and ma'am will give a live demonstration.
Yeah, thank you, Soumya. It was a good presentation.
Thank you.
Have your blind stick. I'll show the demonstration.
Okay, ma'am. Sorry for the inconvenience, ma'am.
It's okay. It's okay, Soumya.
Thank
you can
you.
understand it's.
Thank you.
1 second. I'll share my screen and I'll run the code. As usual, you have to go for Arduino IDE and dump the code and 1 second. So I am showing you the blind stick. So this is the blind stick. You can see people, for blind people, it will be given. This is how they make it. We are using a Arduino board here. We have
your camera is not
Yeah, can you see now? Are you able to see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is the blind stick. Here they've used ultrasonic sensor and Arduino board, LED and buzzer. Okay. When this stick reaches some obstacle, it goes near some obstacle, it beeps. It makes beep sound. See, I am bringing this stick near to the laptop screen, so it is making sound. I'll take it far. It will not make the sound. So if a blind person is walking and if he comes near some obstacle, see, this is the obstacle. The buzzer buzzes and the light will switch on like this.
Ma'am, can you put it close to the floor?
Yeah, I can put it on the floor. See, here there is a table. It is making sound. If I go behind, I cannot show this here. Okay, so it looks like this.
Okay, ma'am.
So if I bring this to a screen, near screen is an obstacle for it now. It buzzes. It alarms the blind person that he's nearing to some obstacle. You have to be careful. So this is how it is designed. They have made it very nicely. The code is here. Can you see the code?
Yes, ma'am.
Yeah, we have a trigger pin in ultrasonic sensor and echo pin. So they are connected to pin number 9 and 8 of Arduino board. In this Arduino board, they are connecting it to pin number 9 and 8. Okay, and we have a buzzer that is connected to pin number 5 and 7. So this buzzer, you can see the buzzer here. The buzzer. It is connected to the Arduino board pin number 5 and 7. And then this is the baud rate that you can see. And serial begin, pin mode, trigger pin is output. Trigger pin is the pin which senses some obstacle. Then it triggers. Okay. Trigger pin output, echo pin. So you can see in ultrasonic sensor, there are two eye kind of things. There are two eye kind of things. So one sends the ultrasonic waves. It finds out the distance. It depends on how much distance we set in the code. Okay. And then if it is nearby, it will make the alarm sound. So it is like waves going, touching the obstacle and bouncing back. Okay. So for that we have used it. Trigger pin, echo pin, buzzer 1, buzzer 2, LED 1. So these are all in pin mode. This is a keyword, the C++ programming again. And we loop it. Okay. So delay we have set it as 2 milliseconds and 10 milliseconds. So digital write. So trigger pin, it writes. If some obstacles are present in front of it, it will write. So duration, pulse, echo pin, height, and distance. So this formula you have to remember. So duration by 2, the whole thing is divided by 29.1. So then if distance is less than 20, I can change the distance. Okay. So that if the proximity can be changed, proximity distance can be changed. Then depending on the proximity, we can make the alarm to buzz. So distance is less than 10, what will happen? So all this if and else are put and coding is done. And finally, we have this product. It's already available in market, blind stick, but our students did this. Your seniors have done this, final year students. Within 2 days, they have done this. So I have to really appreciate their interest in doing these things. So, can you do something like this? Can you give some ideas, participants, which can become a product? This is a product now. Blind stick is a product. Can you make some
water tap? Like when we go and wash our, like when we go to wash our hands, like when it senses our hand, like it is used even in sanitizer also nowadays. Like when we go and show the hand, it will sanitize our hand. So in the same way, even we can use to wash our hands, same way in the water. Understanding? Are you understanding, ma'am?
Yeah, can you come out with such products? Like as a product now, I can say it as a product. It has combined ultrasonic sensor, buzzer, LED, Arduino board. It's a small product. Can you come out with some product like that with these concepts?
Okay, I will tell ma'am. I'll tell it later.
Yeah. Okay. Next, I request Shwetanjali to present her product. Shwetanjali, are you there?
Yes, ma'am.
Yeah.
I'm able to see my screen.
Yeah.
Good afternoon, everyone. I'm Shwetanjali. I'm currently pursuing my final year computer science from computer science engineering. My topic is social distance alarm using the ultrasonic sensor with the buzzer and LED using the Arduino, a device which helps us to maintain a social distancing alarm. Here I'm using the Arduino ultrasonic sensor, buzzer and the LED. Let us see some of the components which I've used in my project. It's the Arduino. Arduino is a low-cost, flexible, and easy-to-use programmable open-source microcontroller board that can be integrated into a variety of electronic projects. This is an ultrasonic sensor. The ultrasonic sensor is an instrument that measures the distance to an object using the ultrasonic sound wave. An ultrasonic sensor uses a transducer to send and receive an ultrasonic pulse that relay back information about an object, which is proximity. This is a buzzer. When a power is applied, current runs through the coil of wire inside the buzzer, which produces a magnetic field. By oscillating the signal through the coil, the buzzer produces a fluctuating magnetic field which vibrates the disc. This movement makes the buzzer sound. This is an LED. LED stands for light emitting diode. Is a semiconductor light source that emits the light when current flows through it. This is the schematic diagram which I did in my project. This is the connections where echo pin in the ultrasonic sensor connected to the 10th pin in the Arduino board. Trigger in the ultrasonic connected to the 9th pin in the Arduino board. The LED and the buzzer negative is connected together. as you see in this diagram. And LED positive is connected to the 11th pin in the Arduino. Buzzer positive wire is connected to the 12th pin in the Arduino. These are the some of the connections. Now I'm going to show my demonstration. Ma'am, cannot able to show. It's showing unmute.
Yeah, Shwetanjali, any problem?
Yes, ma'am, not able to show in the mobile.
Okay, go to the video, play the video. Okay, I have your video. I will share it. Don't worry.
Yes, ma'am. Thank you, ma'am.
1 second. I have her video. She has sent 2 days back. And one thing I want to tell, these are all just hobby projects. They're not KCST projects. The next demonstration, after 2 or 3 hobby projects, we'll be having that KCST projects demonstration also. So these are just hobby projects. They did all this in 2 to 3 days. Within 2 to 3 days, they did it. 1 second. Guys, can you see?
Yes, ma'am. Which help us to maintain a social distance alarm. I am using the Arduino ultrasonic buzzer and the LED. The echo pin in the ultrasonic is connected to the 10th pin in the Arduino board. Trigger in the ultrasonic, which is connected to the 9th pin in the Arduino board. Talking about the LED and the buzzer, negative is connected together and the buzzer positive will be connected to the pin 10, pin 11 in the Arduino board, and LED positive wire will be connected to the 13 pin in the Arduino board. After making all these connections, our circuit is ready. Let us see the working. The ultrasonic sensor sends the wave. These waves are absolutely invisible and come back after hitting an opticals. I have kept a distance of 20 centimeter. If a people who come less than 20 centimeter, then the buzzer and the LED will blink. If the people who go away from the 20 centimeter, then the buzzer and the LED will stop. This is the
output, distance, thank you.
Yeah, in this
all these connections,
see,
our circuit is ready.
in this video, we can see that she has used ultrasonic sensor, buzzer, and LED. When the doll is brought near that ultrasonic sensor, the buzzer buzzes. It is similar concept as blind stick, and
Your screen is off.
showing in the serial monitor also.
Excuse me, ma'am.
Yeah.
Ma'am, the video wasn't visible. I mean,
Video
the
is not
screen
visible.
share. I think you can ask Shwetanjali to stop
One
sharing.
second. Now you can see. Now?
No, ma'am.
Can't you see the video? No.
We can.
Ma'am, it's visible.
Yeah.
We can see.
Yeah.
I'm
I'll play it once
Shwetanjali.
again.
The topic is social distance alarm using the ultrasonic sensor with the buzzer and the LED using the Arduino, a device which helps us to maintain a social distance alarm. I am using the Arduino ultrasonic buzzer.
Yeah, she is doing social distancing alarm. In COVID situations, we need social distancing, right? So if a person comes near a particular person, you can have this buzzing alarm. Okay, so it buzzes.
And the LED. The echo pin in the ultrasonic is connected to the 10th pin in the Arduino board. Trigger in the ultrasonic, which is connected to the 9th pin in the Arduino board. Talking about the LED and the buzzer, negative is connected together and the buzzer positive will be connected to the pin 10, pin 11 in the Arduino board, and LED positive wire will be connected to the 13 pin in the Arduino board. After making all these connections, our circuit is ready. Let us see the working. The ultrasonic sensor sends the wave. These waves are absolutely invisible and come back after hitting an opticals. I have kept a distance of 20 centimeter. If a people who come less than 20 centimeter, then the buzzer and the LED will blink. If the people who go away from the 20 centimeter, then the buzzer and the LED will stop. This is the output, distance.
She's seeing it in the serial monitor.
Thank you.
Thank you, Shwetanjali. It was a good presentation. Good that you had made video and sent me before.
Yes, ma'am. Thank you, ma'am. Sorry for inconvenience.
Yeah, it's okay, fine. That's why I request you all to make videos, whatever you do for that. Okay, thank you. Now I request Rupa to show the demonstration of the project using Blink app. So Blink app is the app where you can do home automation. You can install the Blink app in your phone, in your Android phone, and you can control the lights at your home. Not only lights, you can control fans. And if you go to some high level technology, you can control the geysers, ACs. If you're outside home, you can switch off the lights. You can switch off the geyser, right? And you have seen some ads where they turn on the ACs before they come to home. Have you seen such ads?
Yes, ma'am.
Yeah. So here they make use of the same technology, that is home automation using Blink app. Even you can install it in your phone. I have installed in my phone. I'll just show you. You can go to Google Play Store and you can install it. I'll show that.
It's a green icon with the B symbol.
Yeah, this is the Blink app. It is open green icon. It is green icon. You can control Alexa using this. You can make research over it. There are so many options in this. Yeah, someone has messaged me, accident alarm I didn't get. I'll see the message later. So this is the Blink app. You have so many options in that. I'm just showing devices. So this one you can use it to control your home lights and all. You can do it. You can add a new device here. Okay. So whichever device, and you can connect it through Wi-Fi, connect to Wi-Fi, or using scanner code, QR scanner code also you can connect it. You can do it. It's a good thing to work on. If you are interested, you work on this, you start working on this. It will be really interesting. So that Blink app application, one of the project is done by Rupa, and she will demonstrate it. Now I request Rupa, she is alumni. I requested her to make some time. She out of her busy schedule and come here and show her project. She is a software engineer. So thank you for making up your time. Rupa, are you there?
Yeah, ma'am, I'm there.
Yeah.
Thank you, ma'am. Good afternoon, everyone. I am Rupa. I am from 2021 batch, and I am.
I think Rupa, your video is not disabled. It is. Can you turn on your camera?
Yeah, ma'am. I will turn on. Visible, ma'am?
Yeah.
Okay. Good afternoon, everyone. I am Rupa. I am from 2021 batch. I am currently working at Infosys as system engineer. Today, I am here to share our hobby projects with you. Actually, basically, our interest towards the project started from the workshop. During third semester, we attended the Python workshop, which was conducted by Shani ma'am. And later, during the fourth semester, we attended our Arduino workshop, where we learned about sensors, Arduino, and all. Later, we conducted an induction program to our juniors, where we introduced them IoT projects like controlling LED bulbs using mobile apps and smart irrigation system, robotic arm, and 3D printer and all. Today, we are going to show 1 or 2 demo videos. Let me share my screen. Is it visible, ma'am?
Yeah, Rupa, it is visible.
Yeah. Controlling LED bulbs using Blink app. Here we used Node MCU, LED bulbs, registers, and mobile app, which is called as Blink. It's an application where we can control.
You can go for slideshow mode.
Yeah, ma'am. Okay.
Yeah, it's fine now.
Yeah, ma'am. Blink mobile app, it's most popular IoT app, which is used to control IoT devices and analyzing the data. It will support Node MCU, Arduino, and Raspberry Pi and all. Here in our project, we connected Node MCU to the Blink through the Wi-Fi, and we configured the buttons in the mobile app so that we can control the LED bulbs. Let me show the preview of the app. It was the older version of the app. We used this app for our project. Here you can see new projects, and it has all hardware which will be supported by this app. And it has button and slider, timer, joystick, and etc. We can configure them according to our need. Okay, let me show the demo. You can see when I turn on the switch, the bulb will be blink. And this is the smaller version of automation, which means controlling the electronic device anywhere from the mobile. And next one is smart irrigation system, which will be demonstrated by my friend Nandini. Over to you, Nandini.
Thank you, Rupa.
Hello, everyone.
Actually, Rupa is my student since first year. I took C programming for them. I took AD for them. Then they attended Python workshop. So it is like bondage for 4 years. Yeah. And they were so interested. Every day they used to come to me and they used to ask me, ma'am, today what can we do? What project we can do? What else we can do? Every day they used to come to me after lunch break. They never used to go immediately home, like going home and watching TV. No, after class, they used to come to me and ask this batch, what can we do, ma'am? We'll do something in the lab, ma'am. Like that they used to ask. They were very enthusiastic. This batch now who are presenting, your alumni. Yeah. Yeah, continue. Now I request Nandini to show the smart irrigation system.
Yeah. Hello, everyone. I'm Nandini S. Currently, I'm working for Infosys. My designation is system engineer, working as a backend developer there. So today I'm gonna demonstrate about my project, which is smart irrigation system. This is a smaller version of irrigation. So before starting with the project, let me first explain what our project exactly does. Then the demonstrated video will be played. So next slide.
Once again.
Okay.
Let me reshare.
No, yeah, okay. Actually, the agriculture is the largest livelihood provider in India with a rising population. There is a need for increased agricultural production in order to support greater production in farms. One of the way which is currently in boom is smart irrigation system. The main aim of our project is to minimize their environmental footprint through efficient water use. So smart irrigation system is the combination of an advanced technology of sprinklers with nozzles that improves coverage and irrigation controller that are watering and water conservation system that monitor moisture related conditions on your property and automatically adjust watering to optimal level. In our demo, we have used soil moisture sensor with probes, Arduino Uno, 4-channel relay, motor pump, and a battery. So soil moisture sensor collects data from the soil and sends it to Arduino Uno, where we uploaded the code. If the data received is below threshold value, water will be supplied. If it is the above threshold value, water supplies stops there. So, and yeah, that's all about about this project. So, and next is our final year project called Smart Device for Physically Disabled using Alexa. So before going to next project, I'll like play my demo video here. So play that. So yeah, as you people can see, this is our like till now what I have explained, it is showed in a video. So yeah. So yeah, that's all about this project. So the next final year project called Smart Device for Physically Disabled using Alexa will be continued by Sahana and Charlotte Jennifer Phillips. So yeah, over to you guys.
Thank you, Nandini. It was so nice of you for making up your time and giving explanation of your project. Thank you.
Thank you, ma'am. Thank you.
Yeah. Yeah, now the KCST project demonstration by your alumni. Actually, this project was done by Nandini, Rupa, Sahana, and Charlotte. Nandini, Rupa, you have already seen just now. Sahana and Charlotte will be demonstrating here. So it was selected for KCST, that is Karnataka State Council for Technical Education. That is basically from IASC, Indian Institute of Science. So it was really a good project. We came out with some idea, but it turned out to be a good one. Now I request Sahana and Charlotte to start their demonstration and presentation. So they are projecting how to make slides also for your final year projects. This is how you should make the slides. Okay. And they have combined machine learning also in their project, along with some artificial intelligence. They used Alexa. Now you can have a look at it. Yeah, over to Charlotte and Sahana. You can start.
Hello everyone, I'm Sahana. I'm going to take you through our final year project, that is smart device for physically disabled using Alexa. Initially, we had applied for KCST funding, as ma'am said. Our project was selected and we even got fund. You can ask questions at the end. Do make note of it if you have any questions. As of now, I will start with introduction part.
Yeah, please turn on your video so our students will come to know who are you and all. Maybe they can recognize you. We don't know.
Okay. Introduction. The physically disabled and the senior citizens have a lot of struggle with being independent, and they face a lot of challenges in their day-to-day life. These problems are associated with aging, and being disabled affect their ability to move around. Some people might be affected with muscle weakness or joint problems, pain, etc. And because of this, they will have reduced physical mobility. And this will cause problems when it comes to everyday tasks. And even doing a simple task such as picking up an item and retrieving an item will be difficult. Hence, we are using modern technology to create an assistive device for the physically disabled and senior citizens. Next slide. Existing system. The first point is about Jaco robotic arm is an arm that has a 6-axis movement feature. It can be attached to your wheelchair and it is used to pick up anything that the user wants. It can be connected to any wheelchair as long as the wheelchair has power source and the arm connects to the power source of the wheelchair. Second one, assistive feeding device is a device that can assist the disabled during the meal time. It uses a button to move the spoon between the bowl and the user's mouth, and that way the user can eat independently. Third one, the pick and place robot is a robot that can pick up anything and place it anywhere. It is controlled with the help of a remote control, or it can also be controlled with the help of joystick.
You continue. This is how you have to make slides. You have to tell about the existing system. What are the drawbacks of existing system and what you are going to propose in your project. Okay. Yeah, continue. Sahana, are you there? Charlotte?
Yes, ma'am.
You continue. Network went wrong there.
Okay.
Continue. Yeah.
So I'm Charlotte, and I also graduated in 2021 batch. So I'll be continuing the explanation of the project. So next I will be talking about a proposed system. So we have developed a robot that will assist the physically disabled and senior citizens using high-end technologies such as machine learning and Alexa. The reason we have used Alexa is because Alexa is affordable and it can accept commands from the user in any local language. And the user will give the voice commands to Alexa. And by using image processing, the robot will turn 360 degrees and it will detect and search for that particular object. And commands will be given to Alexa to retrieve the object and bring it back to the user. And there is a customizable arm that is used to carry and lift the load. So now these are the hardware and software requirements that we used in our project. So we used Raspberry Pi, a webcam, memory card, screen, and Alexa. And in software requirements, we used OpenCV, NGRock, TensorFlow Lite, Python, and Arduino Ide. So now I'll be explaining the methodology of our project. So first, the user will give a command to Alexa. And Alexa is connected to Amazon Skills. And Amazon Skills will send what action has to be performed to NGRock. So NGRock is a local server, and we are hosting the Python code on NGRock. Then it will send the required and respective commands to both the Raspberry Pi and Arduino. So the Arduino is connected to L293D motor drivers, which is used to control the motors. The Arduino will process the command that is coming from NGRock, and it will send the command to the motor drivers, which will run the motors, and it will make the robot move in different directions. And on the Raspberry Pi side, the Pi will take the input from the NGRock, and it will start the camera. And with the help of YOLO algorithm and COCO dataset, it will do image processing and object detection, and it will find that particular object. So now I'll be explaining how YOLO algorithm works. So YOLO algorithm is short for you only look once. It is a real-time system that will recognize multiple objects while it is in a single frame. So in our project, we are using YOLO algorithm because YOLO has the ability to recognize the objects more precisely, efficiently, and even faster than all the other recognition systems. So YOLO relies on convolution neural networks, CNN. So what the CNN will do is that it will take the image and it will divide the image into multiple regions. So it can predict the probability and the boundary boxes for each and every region, because YOLO will always see the complete image during the training and testing time. So if we consider an image, what YOLO algorithm will do is that it will divide the image into S cross S grid cells. And S can be any value depending on the accuracy and size of the image. And here the value of S we have taken is 7. And so for each grid cell, a vector is encoded. So we are going to do 2 identification patterns. The first pattern will be using bounding boxes and confidence level. So bounding boxes are used to find the position of all the objects in that particular image. And so the bounding boxes are drawn around each individual object in the image, and the confidence value is set for each bounding box. So a confidence value will tell how much the object is mapping to the actual image from the database. And the next identification pattern is the class probability map. So the class probability map is giving us the assurance that this object is actually that object that belongs to a particular class. Like in this example, we have a dog that is sitting in front of a cycle. So there are 2 objects that are overlapping. So the class probability finds which object is in front and which object is in the back, and it puts the bounding boxes properly for each object. Then we get the object detection in the proper way, and it is accurate. So where the object is present, it can be properly identified. So now I'll be showing the demo of our project. So this first one is the image processing demo. So as you can see here, it will put bounding boxes on each object, and it will also show the confidence value of that object. Alexa, ask robot to close the arm.
Alexa, ask robot to move arm up. Alexa, ask robot to move arm down. Alexa, ask robot to open the arm.
So in this video, we have demonstrated the hand movement using a medicine bottle. Now I'll be showing the next video where the body of the robot is moved.
Alexa, ask robot to move forward. Alexa, ask robot to move backward.
Now this video is to demonstrate the robot searching for a particular object.
Alexa, ask robot to find teddy bear.
Finding teddy bear in the surroundings.
The future enhancements. The first one is we can add a multi-dimensional camera setup. This will allow the camera to face different directions without having to turn the robot. The next one is that the robot can find the path to the required object using path mapping, and it will automatically have the robot retrieve the object for the user. Next is improved accuracy. So by training the system on various different objects, it will give a better and faster object detection. Next is to implement self-learning. So when the robot can learn different objects using machine learning through trial and error. And the next is with addition of night vision, the robot can detect objects in the night or in the dark with better accuracy. So in conclusion, our project titled Smart Device for the Physically Disabled using Alexa will be able to assist the physically disabled and senior citizens by helping them in their day-to-day activities. And it will also help them be more independent. So Alexa is used to take the input from the user, and robot will search for that particular object from its surroundings. And commands will be given to Alexa, and then the object can be retrieved and it will be brought back to the user. That's all, ma'am. Thank you.
Yeah, thank you, Charlotte and team. Sahana, for explaining your project, and you showed how to make the PPTs. So this is how the final year project PPT should be. You should have your existing system, proposed system, and methodology. All those things should be present, and they have made a wonderful project. Can you come out with some project ideas after looking at their project? Can you suggest some ideas, participants?
Yeah, well.
Any queries to them? Using Alexa, Alexa makes use of artificial intelligence, right? NLP, natural language processing. When the chatbots, they make use of NLP. Okay, thank you. Now I request Sri Charan to take over the session.
Hi, ma'am. Hi, everyone.
Can you turn on your video, Sri Charan?
Hi, ma'am. Am I visible?
You're visible. Yeah, you can talk.
Yeah, ma'am. Yeah, hi, guys. Hi, everyone. I am ex-student of AMC. So basically, my information, I am... Sorry?
Yeah, you can continue. Continue.
Yes, ma'am. Yeah, I'm ex AMC student. I passed out on 2020, and even my project was selected for the KCST. Even my project guide was Shalini ma'am, and yeah, we had a lot to learn. We learned everything, and according to my experience, what I have found is that if you have many projects in your resume when going to interviews, so they'll concentrate on your projects rather than asking you questions on which language do you know and everything. They just see that how well versed you are, how you can use the other functionalities. Basically, they will not judge you on how many languages you know. They'll see that do you understand the logic of any particular thing, or will you be able to understand the logic what they want. Okay, so that will be the basic thing what they'll be seeing. And trust me that there was an incident which happened with me. So there was a company, name is not required now. So in that company we had been for a what you call sales job. So seeing my and one more my colleague's resume, they actually called us for a technical interview. So that is the power of the projects which you will have. Even if you go to a business company, if they have technical in that company, they'll try to push you into technical. And one more incident that took place is in one of the company, they just saw my projects. They asked me about my projects. After that, not ask anything else. So directly they gave the seat in that company for me. So these are few incidents which happened with me because of my projects and the knowledge which was on the projects I had. So yes, this is my experience from doing all the hobby projects and getting a good projects in the final year. Yes, ma'am. Anything else, ma'am?
Yeah, actually, I requested the whole team to be present here. One more person from his team, Tejas, one more is Vajula and
Mauli.
So all are equally capable, and they were very good in coding. Actually, Sri Charan, he got placed in more than 1 or 2 companies. The situation was like that, like he has to choose the company. He only has to choose the company. Companies, more than 2 or 3 companies have chosen him. He has to choose one among them. It was the situation. He's very good at coding. And what I want to tell is he's a very humble person. Whenever I need his help, he'll come to college. He'll help me out in IoT lab. And I cannot forget, all alumni are like that only. Even Charlotte, Sneha, and the Charlotte group, Nandini and all, they're equally good. And one more, Tejas, he is also equally good. He is very, very skillful, and he is in US now. So he's doing MS, and 2 more people, they didn't come. They are busy. They're not in station. I requested them also. So yeah, now I request participants to project their project. Anybody is willing to project the project? Participants?
Yes, ma'am. Guys, anyone who's interested to present your hobby projects, no matter how small or big it is, you can come forward and demonstrate. Yeah, who's it? Can you come up? Can you switch your camera on? Yeah, I think someone told yes, right? Yeah, if anyone is interested, you can come up, introduce yourself, and demonstrate your projects. It's a great opportunity for you guys. We have seniors also. They could help you. How can you improvise on it, or start a new project or anything like that? And even Shalini ma'am will definitely help you guys out with whatever issues you have in that particular project.
If you don't have projects to project, at least you can tell about the projects which you have done.
Yeah.
Excuse me, ma'am.
Yeah.
Yeah, ma'am. This is Aditya, and I'm from ISC department, first year. Yeah. For now, this is not going to working, but this is I have done in my in first PU. This is what in the morning what you have showed that using Arduino, that using LDR, and we can do a sensor where if the LDR got brightened or if the LDR is darkened, the light will glow. The same project has been done on the PCB board, where it has been you can see in the backside. And I think it's been seen. Yeah, it's been this is a PCB board where we have marked the copper in copper plates, and we marked we made the using PCB one app. We have made the design, and this at no time this is not working because of some issues within the connections. But it's the same thing which has been using a IC. And IC 555, it's the IC has been used here, and a register for because of the functioning, but to care for our bulb, and one LDR has been used. This is my project, which has been done in my first view.
Very nice, Aditya. A very nice attempt. You have tried out something which is related to.
Yeah, it's working, but still some circuit problems are there. It's already 2 years over. That's why it's not working. The same project.
Have interest in this.
Yeah, ma'am.
Thank you.
Thank you for giving me this opportunity to show that I have made some projects. Thank you.
Yeah.
Thank you so much, Aditya. Also, ma'am, I think a few participants were asking if they can get the PPT of the seniors project presentation.
Yeah, surely they can get.
Okay.
And I saw one person has messaged me in my WhatsApp. He has asked, ma'am, can we use Tinkercad? Before he didn't use Arduino, he used Tinkercad. So Tinkercad is a software where you can simulate the concepts. Okay, those who are in third semester, you have come across Xilinx Multisim, isn't it? So like that, yes, we have Tinkercad. I'll just show you once here. Tinkercad, you need to log in. So sign in with Google. Yeah, here you'll have various options. You can go to circuits, and you can create a new circuit. Yeah, you have options here. Those who have done Xilinx Software Lab, you can understand, you can drag and drop. Suppose you want Arduino,
yes, ma'am.
You can place the Arduino here, right? Suppose you want to glow the LED, you can choose the components. I don't know the name of the messaged me. Is this the one you did?
Yes, ma'am.
Yeah. So this is before starting with actual components, you can experiment with this Tinkercad. Various components will be available in the right hand side. So you can use these components. You can drag and drop, and you can name the component here like LED and all. Just like Xilinx software, what LDR is here. If you want to work with LDR, you can work with LDR. Just connect it, that's it. ultrasonic sensor is there, buzzer is there. Like I showed the actual connections on the board, you're going to make it with the software. It's for beginners. Just connect it, pin number 13 and all, ground pin number 13, and you can see the results.
Yes, ma'am.
And after connecting it, you can click on Start Simulation. Will initialize the simulation. So if I take LED, let me try. I didn't do any rehearsal for this because the person asked through WhatsApp message, so I'm planning to do it. That's it. Okay, I'll just see it. So it is, this is cathode and this is anode, it is showing, right? So LED glowing, it's blinking.
Yes, ma'am.
Yeah, I just connected anode to 13. 13 is inbuilt Arduino LED, and cathode to ground. So you can see the LED blinking. This is one of the experiments, what I could show. You can try many in this. It's for beginners. Before doing on actual boards, you can start with this. Yeah. Any other doubts?
Ma'am, ma'am, can I know the highest salary offer for the college, ma'am?
See, I'm not in placement department. So sorry, I don't know.
Okay, ma'am. Ma'am, I have another question, ma'am. Will ultrasound scanner, will ultrasound sensor sense anything? Anything it comes to something? It comes to its near, ma'am.
Yeah. No, anything which comes to its near, it's not like that. We are going to program it in such a way, like for 10 centimeters, 20 centimeters distance. Okay. The code we write in IDE, right? Arduino IDE, there we set the distance.
Okay, ma'am.
If it is in that much range, it will make the buzzer sound. So what happens is, there are two eyes for ultrasonic sensor. One eye, it sends ultrasonic waves. Ultrasonic waves, its tendency is to hit some object, which is solid object, and bounce back.
Okay, ma'am.
So based on that phenomena, it works. So the distance, say I want 20 centimeter distance, within 20 centimeter proximity, if something is there, make buzzer buzz. It's like that. That proximity, how much distance that ultrasonic waves need to travel, that we can decide it through programming.
Okay, ma'am.
Now I'll see the chat box. I have messages. Ma'am, for any further query or advice, how we can contact you? Can you share your number or any source of contact? Yeah, I'm sharing my phone number.
Excuse me, ma'am.
Pardon me?
I have a doubt. I mean, this guy who asked the question previously, same doubt. I think he was not asking about distance, but I think he was asking about if the object can sense anything and everything, or only few particular things. You know what I mean?
Yeah. It can sense all the opaque bodies. Opaque.
Okay, ma'am. Thank you.
Opaque in the sense solid bodies. Yeah. Yeah, I'm giving my phone number and
Yeah, meanwhile, if anyone is ready to demonstrate your mini projects or hobby projects, you can go ahead and demonstrate. I think there was a participant named Harsh.
One of the candidate has told, yes, we can see the Git pages of the projects too. Yeah, you can go to GitHub. Are you aware of GitHub?
Yes, ma'am.
GitHub is again an open source repository where you can code for projects and put it there, and you can allow people to access giving the permission. That is GitHub. It's a cloud, basically, where we are going to store the code. There, some people might have saved the projects. You can use that.
I think he specifically meant for the seniors projects, ma'am.
Seniors projects, yeah, seniors projects are not there in GitHub. So I have a GitHub account. I will plan to put the projects in the GitHub. It's a good hint. Yeah, I will do it.
Yeah, as in when ma'am updates it, we'll be sharing the links in the
Yeah, I'll
group.
share. I'll share. As of now, it's not there. I'll do it.
Yeah, I think participant named Harsh was ready to demonstrate it. Is he in the meet? Harsh, are you there? Okay, Meghna, are you there?
Yeah, Harshit.
Okay, you can go ahead, I think.
Yeah. Good afternoon, guys. I'm Meghna. I'm IEEE student member. First of all, I would like to thank Shalini ma'am for giving us an opportunity to demonstrate a project. I'll be sharing my screen. Just a minute.
Meghna, I think you could switch on your camera as well.
Yeah, give me a minute.
Yeah.
Is my screen visible? Could anyone confirm if my screen is visible?
Just a minute, Meghna. Yeah, your screen is visible.
Okay. Am I visible? I've turned on my video.
Yeah, you can go ahead.
Okay. So guys, this is a very small hobby project. We all have attended the morning session, and ma'am was telling that we can use IoT and Arduinos in real life applications, and one such application was the traffic lights and traffic junctions. So this project, we were a team of 4, and we did this project last year during, I think during a 4th semester or something, we did this project, and I thought I could just demonstrate it here. So this project, just a minute. Okay. So as you can see, this is a Arduino Board. This is the Arduino Uno, and I have used a breadboard. Now in this project, I have considered 2 junctions, 2 light junctions, and how will you code it such that each of the lights keep turning on automatically. And you can also, this is Tinkercad, it's a very good platform for to learn coding and to learn Arduino project. Not necessary that you have to have the hardware in the initial stages. I would suggest the beginners to use this Tinkercad platform. You can also code it here, and then you can start the simulation and check if it is working. I know in the beginning stages we are all not confident about the code. We are worried if the Arduino gets damaged. So you can first check the code here, and then if it works, you can feed it into the Arduino board. So this is the code. In this code, I have used, as I told, I have used 2 junctions. I would just start it. And you guys can observe first the yellow lights are turned on. It will wait for some second, and then when in the first junction, when the red light is there, there is green light on the other junction. So which means one side of the vehicles will keep moving and the other one will stop. So I have coded it for now in this code. As ma'am told, it's all using keywords. So first you need to set up, give the pin numbers and then the light numbers. After that, I have created a delay of 15,000, which means it's 15 seconds. After 15 seconds delay, first, as you can see the code, I'm sorry, when the when green is on, both the yellows are high. Green is low, both the yellows are high. And after a delay of 5 seconds, that is so in both the sides, yellow will be on for 5 seconds. And then in the next turn, yellow will be low, red will be high on one side, and green will be low on the other side. That is what the next consecutive code comes up with. When yellow is low, red is high, and again yellow will be low, red will be low, and green will be high. So basically for all the 6 lights, you have to give which is low, which is high. And again, you have to follow the same steps for the next, it's like a loop. So this was the first project which we did. Yeah, I think this is the other lights. After this, we also had one more project that was on pedestrian crossing as well. I'll just share that screen too. Just give me a minute. Yeah. Now, in this, basically, this isn't followed in India, but in countries like Sri Lanka, what pedestrians do is they will have a button kind of thing along with the traffic junction. So whenever pedestrians want to cross the road, they will just click that button, and that button will stop the vehicles. It will give red signal for the vehicles for a few minutes until the pedestrian crosses, and then again the vehicles can keep moving. So we have used that idea here. I'll just start the simulation first. Yeah, so you can see green is on. Now, until I press this push button, until I click on this push button, the green will still be on, which means vehicles will still keep moving. Now I've pressed the push button and it just went to yellow, and now it will stop. So at this time, the pedestrians can cross, and after some time, automatically green light will turn on. And the code for this is also written here. This is the code. So you'll have to just define a push button and then introduce it in the code, in the loop. Yeah, that's it. Thank you. Thank you, ma'am.
Thank you, Meghna.
Yeah, thank you, Meghna. Very nicely explained using Tinkercad.
Thank you, ma'am.
Anybody else is willing to project? Yeah, I think feedback form is ready in the chat group. You can access it. Till 3:40, it will be open, I guess.
No, ma'am, it will start taking responses from 3:40, and we can take responses.
It start taking responses from.
Yes, ma'am. Yeah, those whose responses have already been corrected, don't worry, we have your data. By 3:40, we'll be reopening the Google form again. You can fill in your details then.
Ma'am, can you share your
IoT
contact?
workshop feedback form, the form or IoT workshop feedback form is no longer accepting responses. It's coming.
Yeah, we'll be opening the responses in 2 more minutes. Don't worry.
Yeah,
ma'am.
And those who don't have their USN, what should we fill instead of USN?
You might have a serial ID, right? You can fill that, or if you do not have a serial, okay. Done. Yeah. Meanwhile, if anyone is interested in demonstrating your projects, also guys, those who have Meghna and Aditya, you guys have put in some efforts to demonstrate your projects. So you can ping in the IoT workshop groups. You'll be getting your certificates. You can ping in the admins.
okay, thank you.
Yeah. Anyone else? Yeah. Also, guys, in the feedback form, make sure you're mentioning your institutional IDs or any Gmail ID. I mean, it has to have a gmail.com extension because that will be easier for us to generate certificates. Do not mention anything other than your institutional ID or Gmail IDs. Anyways, will be you can text us in the group as well. We'll be accepting participant messages. If you do not receive your certificates within a week, you can text us in the group and ask us to resend it.
Harshita, they're asking if they don't have USN, what should be done?
Oh yes, ma'am. They can fill in their serial IDs.
Okay.
Yes, ma'am. Yes, guys, please fill in the feedback forms. Only if you fill in the feedback forms, you'll be receiving the certificates. Yeah, the feedback form is accepting responses now. You can just check. Yeah, the link will be shared once again. Can we please have the link in the chat box again? Yeah, they'll be sharing the link. Yeah, thank you.
Excuse me.
Yeah.
We are given with a serial number with the ECS form. Can we fill that?
Yeah, no issues. You can fill in that.
Okay. It's given by college management itself.
Yeah, no issues.
And
Also,
then
guys.
USN is approved.
How many digits is that number?
Sorry?
Oh, then I'm asking him like the serial number which is mentioned in the college. How many digits is that?
It's in the form of ECS and 2 numbers.
Like in where is it mentioned? Like fee receipt or something else?
No, our when they do the classes, they have sent for us.
Yeah, no issues. You can mention any of the serial IDs. That will work. No issues. Yeah, that's what. Those who didn't get your USN, just fill in your serial IDs given by your departments. Yeah. Also, guys, make sure you mention your full names because that names only will be printed on your certificate. So make sure you fill in your full name. Yeah. I think Syed wants to present one of his project. Syed, are you ready?
Hi, yes.
Syed, okay.
Yeah, this is a simpler version of the social distancing one which ma'am had done. So this is made with a IR sensor. Just a second. So see, this is done with an IR sensor, okay? So if anything comes close to it, the buzzer will start beeping. Just a second. Or maybe there's some loose connection. What happens is, see, this is an IR module. This is a power module. So here you can select whatever the voltage you want. There is 3.3, there is 5 volts in this. So rather than connecting the battery directly through the breadboard, this is one alternative for it. I don't know what's wrong, but it was supposed to work. You guys get the idea, right? This one is a sender and this one is the receiver. This sends the IR IR. This receives it. So if something is coming into its proximity, it will start beeping. I don't know why it's not working at the moment.
Amele.
Yeah, good. You were able to come forward and show whatever you have done. Very nice.
Ma'am, can we have your contact number?
Yeah, I have messaged in chat box. Once again, I will give.
Hello.
Hi, hello.
Guys, please mute yourselves. Yeah. Next is anyone who wants to demonstrate your projects? Yeah. Ameem and Ameem would be getting the certificate of appreciation. You just ping in the IoT workshop group.
What we should fill for IEEE student member?
Sorry?
There is a question as are you an IEEE student member and your IEEE student membership ID?
Yeah, if you are an existing IEEE student member, click on yes, and you can mention your membership ID there. If you're not
No,
a
I'm
student,
not a member, but I like to become a member.
okay, okay, you're interested in becoming a student member.
Yeah.
Okay, yeah, in the last question, we've asked your contact details. You can just drop in your contact details. Our team will get in touch with you.
Yeah, Harshita, many students want to become the IEEE student chapter members. So
Okay.
what's the procedure actually?
Yes, ma'am. I think they'll be sharing it in a while, ma'am, in the groups itself.
Okay.
Yeah. Guys, if you just want a brief, I could give that now itself. Basically, you have to check in into the IEEE.org website. There you have, if I'll be very specific, this is for students of AMC Engineering College, since this is a student branch. So you have to join as a student, fill in your registration details. It'll be basic details, your address details and your college details. Once you fill in those details, you would be redirected to the payment page. And talking about payment, currently IEEE has discounted prices going on. The usual price for joining IEEE in dollars is $27. Right now, IEEE has 50% offer going on, so you can join as a student member in $13.5 itself. So yeah, anyone who's interested or want to know more about it, we'll be sharing the brochures as well in the groups and the posters of IEEE as well, so that you get in-depth knowledge about how exactly we work. So yeah, this is the procedure. The links and all the related stuff would be shared with you in the WhatsApp group itself. So anyone who's interested, you can check the WhatsApp group, and we'll be opening the WhatsApp group for participant messages. You can interact with your other student members there.
Thank you, Harshita.
Yes, ma'am.
I think many will be interested to join IEEE student chapter. So what are the benefits we can get out of it?
Yes, ma'am.
Okay.
Firstly, yeah, does anyone? Yeah.
Go ahead.
Yeah. So basically, firstly, a very basic benefit that you'll get from IEEE is you can host events from your college. Just like this event, we hosted this event in collaboration with CSC, IEEE in collaboration with CSC. So you can host colleges inside your college and globally as well. Any event you're hosting inside your college can be attended by students outside the organization, outside the state as well. Like today, we had a participant from Nigeria. They were very keen on attending this particular workshop, and you get access to many research papers. So in final year, many have a mandatory requirement to finish a research paper in their degree. So if you are interested in writing research papers as such, you'll get access to a wide range of research papers in various domains, ranging from technical, non-technical, humanitarian, all grounds. And then you'll have access to IEEE Potentials and IEEE Extreme. Those are wide range of magazines and articles available in IEEE. So there are various benefits if you join IEEE, and definitely it is a learning curve. You get to learn a lot of new things. You'll get to meet a lot of new people. Networking is important, as you know. Like without networking, it really gets difficult in this current scenario. So yeah, there are various benefits on joining IEEE. So we will definitely be sharing the brochures and posters with you that will contain in-depth information about it. Yeah. Yeah.
Harshita,
Yes,
how many students from other colleges participated? Any idea?
Yes, ma'am. We have more than 150 students from other colleges. We had more than 150 registrations, and even while logging in, I noticed a lot of students from other colleges.
Okay, that's good.
Yes, more than 100 students.
Yeah. Yeah. Today is Saturday, and you all made up your time to learn something or to be with me for some time.
No problem.
I expect the same thing in future also. Whenever you're free, you can come to me and we can discuss. It's not that I'm going to guide you, I'll be with you. Even I'll be learning new things along with you. So I thank you all for attending the workshop, being patient from 10 o'clock to 4 o'clock. Thank you. And the same day, we had many other workshops from AMCC and other colleges as well. But still you made up your mind to attend this workshop. I thank you for that. Yeah, thank you for your support.
Ma'am, can we meet you in offline classes also?
Yeah, you can come. I'm in CS department. Second floor. Yeah, you can come.
Guys, could you please share the feedback link again? I think a few of them have not filled it yet. Team?
Hello, ma'am.
Yeah, tell me.
Ma'am, I had made a project in first PU of solar tracker. Can I
Solar?
display tracker, ma'am? Solar tracker.
Okay. You want
Can I
to
display, ma'am?
Yeah, you can display.
Hello.
Yeah, your screen is visible. You can go ahead.
Yes, ma'am. Yes, ma'am. This was my solar tracker, ma'am. It tracks the sun, ma'am. I will just display it.
So wherever the sunlight is there, it turns toward that side. It's like that. Are you explaining something? Yeah. How are you able to do it?
Ma'am, there was a competition for computer science, ma'am, in first PU. I and my team had made this with Arduino, and I have it, ma'am, now, but unfortunately, the server motor is not working. So I cannot display in live.
It happens with electronic components. If you don't make it work, they will go off.
Yes.
Yeah, nice. Anybody else is ready to project?
Yeah, nice work, Kushal. You can just ping in the admins and show the project or show any demonstration of it. We would be sending away the certificate of appreciation to you.
Yeah.
When will the groups be formed, ma'am?
Sorry?
When will the groups will be formed, ma'am?
For what?
for this certificate issue.
Okay, that Harshita will tell.
No, there won't be any groups as such. You guys are already in the IoT workshop groups, right?
Are you in WhatsApp group?
WhatsApp group
Yes,
I'm talking
ma'am.
about. Okay,
I'm not there.
Yeah. This the certificates would be directly mailed to you. You can just confirm us once if you've received it or not.
I'm not in IoT group, so you can just add me.
Okay, I think they have mentioned our contact numbers. You can just ping us. We'll be adding you into the group. Guys, can you please share the contact details again?
We can put it in the chat box, no?
Yeah, we'll be putting it in the chat box. Also, guys, don't worry. We'll be sharing Shalini ma'am's contact details with you in the WhatsApp group as well, if you're not able to find it in the chat box. Because there are a lot of messages, that's a probability. We'll be sharing it in the group, don't worry. If you have anything to ask to ma'am or senior students, you can ask that now. Yeah, for those who are not in the WhatsApp group, I think the contacts have been sent in the chat box. You can just note down and message either of them. Is anyone else interested in demonstrating your projects? Or if you have any Q&As, queries to ask to ma'am, you can ask that. Also, guys, please note that only fill your contact details under if you're interested to join IEEE. If you're an AMC student, this is only for the in college student branch. Do not confuse. Okay, we'll be adding you to the group, Vijay Krishna. Have you filled the feedback form?
Yeah, I have filled it.
Okay, done. We'll be adding you, no issues.
Thank you.
Yeah. Thank you, everyone. Now we have a closing notes by Neha Srivastava, IEEE student member.
Yes.
Oh, just a minute, Neha. I think someone is interested to talk. Yeah, Sundar, you can.
I'm interested about the traffic signal, ma'am. Actually, when the ambulance comes, there will be in the opposite way also the signal will be on, like green. If in the signal itself, if we fit any like sonar or any length detecting machine about the red light, then within half kilometer, if it senses it, only the way the ambulance comes, it should be on green light.
Yes, sir. You have come out with a very nice idea. Actually, there should be a system where the traffic signal senses the ambulance light and allow the ambulance to go, right? Yeah, that system is not there. It's a very good idea. I think you can start a project over that. Think of it.
Yes, ma'am.
Yeah.
Because when ambulance comes, even on the opposite side, there will be green light. Now, the ambulance will move clearly.
Yeah.
So if it senses that light, red light, and it turns on the green light only on that way, then the ambulance can go easily.
Oh, yeah, exactly. So there are no such system where we can sense the ambulance path and be alert and allow the ambulance to go. There is no such signal system. So yeah, we can think of such type of innovations. Good idea.
I also have an idea regarding avoiding the accidents using ultrasonic sensor. That's why I asked the before a half an hour. Avoiding accidents.
In cars, you might have seen when you're taking reverse. The recent cars have ultrasonic sensors. If it is proximity to a particular object increases, it beeps. Right.
Is it installed in every vehicles or only cars, ma'am?
As of now, in cars we can see. You can put it into your bike also if you have a bike with you.
Okay, ma'am.
IISC 679, what was your doubt exactly? I didn't get you. What email are you not able to use? Can you unmute yourself? And or you can put in the chat box as well. Yeah, very innovative ideas, guys. Vijay and Vijay Krishna and Sundar. Try in and implement this as projects, as ma'am said.
Actually, I didn't respond in the feedback form for my number for joining in IEEE. Is there any other way to join in IEEE, ma'am?
Yeah. Just message the admins. We would be contacting you.
Yeah, okay.
Yeah.
Harshita, those Nigeria students are here. Nigeria students.
I'm not really sure, ma'am. They were like, they have like 4-hour time gap. So they were not sure when the event was starting also. So I had to text them and tell to join.
Okay.
And they were very much eager also, like they couldn't register. So they mailed me that they want to register.
Oh.
Yeah.
Okay. So they didn't attend, you didn't come.
No, they attended, ma'am. They were there until 3 or something.
Oh, okay. Okay. That's nice.
Yeah. Yes, guys, the Google form has stopped accepting responses. Will not be accepting any responses anymore. Thank you so much, ma'am. We really like you. Thank you a lot for taking in your whole day for teaching this new concept to us. I'm sure many more students will come up to you and ask about this concept, how to get started. Even we are excited to learn from you. Although you didn't teach any of the current third-year students in our section, we are really connected to you. We expect to learn a lot from you. Thank you so much, ma'am. Now we have Neha Srivastav giving away the closing notes.
Thanks, Arshita.
Yeah. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, Neha Srivastav, on behalf of IEEE Student Branch AMCEC, extend a very hearty vote of thanks to the management and the honorable delegates who blessed us with their encouragement. I must mention our deep sense of appreciation for Dr. Malika Arjuna Babu, Director of AMCEC. I also wish to express my gratitude to our principal, Dr. Girisha C., for providing encouragement and support. I would also like to extend a special thanks to HODs of all the respective departments as well. I'm very grateful to Dr. Janita J., IEEE Student Branch Counselor, for giving us an opportunity to organize this event. I especially thank and appreciate Professor Shalini ma'am for coming up with such an amazing workshop. The way she conducted the workshop was exemplary. I heartily thank all the participants for their active participation in this event, as no program can become successful with a single person. So I extend my big hearty thanks to our IEEE branch members for their support. Thank you guys for making this event successful with your contribution. Thank you.
Thank you.
Thank you so much, Neha. Guys, if you're all comfortable, maybe you could switch your cameras on. We can click few snaps of the event. So the student members, I'd request you to please switch your cameras on. Someone else also please take snaps. I'll be taking as well. Yeah, thank you so much, guys. Yeah, I request all the student members to stay back for a small meeting, and the others could leave. Ma'am, you also.
Yeah, thank you. Thank you for all your.
Thank you, ma'am. Thank you, ma'am.
Since a week, I'm bugging you. So actually, I felt happy that such cooperative students, supportive students are there. I was very happy to be with you. Okay, we shall expect some events ahead also. Thank you. Yeah.
Thank you, ma'am.
Yeah. Ma'am. Bye bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, guys. Thank you. Thank you. Sank